Very good evening, all my dear friends. Welcome, Vanakkam, Suswagatam. So, all my dear friends, welcome to each and everyone to yours Unacademy NEET English channel. This is your HSP Baba, and I'm here with Reaction Mechanism Part 3. 1 and 2 we have completed. Before I let you know rest of the other things, first of all, I would like to see in the chat section that everyone, am I audible as well as visible to all of you or not? All my dear students. Yes, Selva is there, Veda Chandani is there, Samria is here. Oh my God, top-notch students are present. Right now, what I can see that all my students, those who have shown the stupendous performance, they are present right now. Now, my dear students, everyone show me the Josh, because this reaction mechanism part 3 is going to be very, very important. Why? Because most of the questions, they will come from this part only. Hey, everyone. So how's the Josh? Do let me know how's the Josh. Selva Bharti is there, Dharma Teja is there, and I can see Krishna is also there, Priyanka is there, my dear friend. That's really awesome. But likes are less. What I can see, kids, why the likes are less? When everyone is present, then why the likes are less? Mark your attendance. Hey, everyone. Mark your attendance. Attendance marking means that you are ready for this awesome session. Now, if anyone new to this channel, let me tell you, this is your HSP Baba, Harendra Singh Parihar. I did my MTech in 2004, 99 MSc topper. I have been teaching for the last 24 years, produced number of top 10 ranks, top mass selections, and these students, those who are getting 363 marks, they have jumped to, they jumped to 666. I'm not saying because only of this chemistry, but the motivation, what the transition, or whatever the, you can say, escalation they are going to get because of that. So all my dear students, everyone, if you're new to this channel, if is there anyone who is new to this channel, yes, subscribe our lovely channel, the rank producing channel, authentic channel. The team is really awesome, my dear friends. And if you haven't, smash the like button. Everyone, hit it right now. What I want to see that, yeah, that's really fantastic. So let's deal with the first reaction that you can see, Reimer-Tiemann reaction. Vanakkam, Harni, Vanakkam, Jyoti is there, Surtika is there, RB Bichu is there. My dear friends, first of all, you have to make a promise that you are going to be regular over there, because now your examination is approaching, my dear friends. And before that, let me tell you, in this session, this is not going to be a very lengthy session, but during the session, you're not going to escape. You're not going to leave, because regularity and discipline is that thing which is going to give you success, my dear friends. So once again, I would like to say, likes are less. Everyone, mark your attendance. Shivakumar is there, Thara Mohan is there, Rakhi is there, everyone is there. So let's start with the Reimer-Tiemann reaction, and I'm going to give star to this reaction. This reaction is getting 15 stars, because this reaction holds a hell lot of weightage for examination. Now let's see what this reaction is, Reimer-Tiemann reaction. First, I will tell you the reaction, and then after that, the mechanism and the important things which are required for your examination. Try to put it in your hippocampus right now, in your brain, so that it can form a memory. Now, this is phenol. We know that this is phenol. Everyone, if you are going to appear for your board examinations, you have to write phenol. Phenol, when it is going to react with chloroform and KOH, this will produce the major product as orthohydroxybenzaldehyde. Now, everyone can say this is orthohydroxybenzaldehyde, but my dear students, its nickname, its common name, its journal name, that you have to know, my dear students. This is known as Buddha Surya after a long time. Akanksha is there. Welcome, welcome all my dear students. So, its name is salicyldehyde. Salicyldehyde. All my dear students, you have to remember, you have to note, this is salicyldehyde, and examiner is really interested in this name. Godwin is there. Wow. Wow, that's really fantastic. Now see, this is known as salicyldehyde, and this is going to be the major product. And who is salicyldehyde? The orthohydroxybenzaldehyde. If I say its another name, then its another name is orthohydroxy. My dear friends, wherever you are seated, everyone say, just you remember those days, your childhood days, Baba, black ship, or twinkle, twinkle, little star, your madam was telling you and you were repeating till now, it's there in your brain. So whatever I'm saying, you have to repeat loudly. Whoever is laughing, don't worry about that. Everyone say, everyone. Thank you, Salini ji, thank you. Now everyone say orthohydroxybenzaldehyde. Orthohydroxybenzaldehyde. That is salicyldehyde. That is salicyldehyde. That is salicyldehyde. Now, my dear students, if this phenol is going to react with, carbon tetrachloride and KOH, all the KOH, they are being alcoholic. Now you will get major product as OH, COOH. This is orthohydroxybenzoic acid, that is known as salicylic acid. Now, my dear students, let me tell you one thing. This OH, that phenol, is ortho-para-dielectric group because it is donating electron through plus M, or you can say plus R, at ortho as well as at para. But ortho one is being the major product, and this is known as salicylic acid. Now, my dear students, you must be thinking about which one is Reimer-Tiemann reaction. Reimer-Tiemann. Tiemann has become nowadays Tiemann. You remember what I'm talking about. Tiemann has converted to Tiemann, Reimer-Tiemann, and both of these reactions are known as Reimer-Tiemann reaction. The salicyldehyde formation is also Reimer-Tiemann reaction, and the salicylic acid formation is also Reimer-Tiemann reaction. Right now, you have added to your brain what I can see. Satyam is there, Abhyanashri is there. Satyam, everyone says salicyldehyde and salicylic acid formation is Reimer-Tiemann reaction. In shortcut, you can call it RTR reaction. RTR, Reimer-Tiemann reaction. Now, let's deal with the mechanism. What question examiner will ask? Now, see kids, before moving towards the mechanism of the reaction, let me tell you the importance of salicylic acid. So let's see importance of salicylic acid. Importance of salicylic acid. Right now you have to keep this thing in your brain. Importance of salicylic acid. Just see how the salicylic acid looks like. See kids, this is your salicylic acid and it is made up of two parts. One is OH, one is COOH. Now, my dear students, before I'm going to write down the reaction, one thing I'm going to tell you, very, very important thing. Just like we human beings, if anyone is no more in this world, we'll write, suppose Ramu got died. No more Ramu is in this word. We'll write late Ramu. Now these chemicals saying, oh, human beings have used late before the name, I will use late after the name. Just like benzoic acid. What do you say? Benzoate. Salicylic acid. What do you say? Salicylate. One thing you have to keep it in your brain. If this H has gone, we will say salicylate. If this H has gone, we will not say salicylate, right? Now see, my dear friends, if this is going to react with CH3COCl. Now you see, this is acid derivative. When this acid derivative will not react with acid, it will react with OH, and this proton will go away along with this chloride. So ding 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 ding, has gone, ding. Now what you will get? You will get compound like this. O is there, COOH is there, and O is attached with this COCH3. COCH3. Now, my dear friends, should I call it salicylate? No, because acid's H is still there. I will say acetyl salicylic acid. What's its name? Acetyl salicylic acid. Acetyl salicylic acid. Everyone say acetyl salicylic acid. In shortcut, you can say ASHA. ASA, ASHA. It is a painkiller, well-known painkiller, kids. Well-known painkiller. That is aspirin. Now, my dear friends, this aspirin also saves us from heart attack because it is blood thinner. So this is acetyl salicylic acid. Now, my dear friends, what I'm telling you, not only acetyl chloride, if you are going to use, even if you are going to use acetic anhydride, CH3, C double bond O, C double bond O, CH3. Now, this H will go along with this O negative, and there HCl has been removed. Here acetic acid will get removed. You will get the same product. Either you are using acetyl chloride or you are using acetic anhydride. In both the cases, product will be same. These two are known as acetylating agents. Now, my dear friends, see, at the same time, we can't forget about that if this compound is going to react with methyl alcohol. Hey, methyl alcohol, you are the one who is belonging to the family of OH group. So OH will not react with OH. Remember that this is the most important thing which the students most often they are going to lose marks, my dear friend. This OH will get away with this H. Now see, it's really fantastic thing. No. This acid will lose its OH and this hydrogen will go. Remember that. Acid is famous for losing its H plus, but when acid comes in contact with alcohol, acid losing its OH. Now what compound you are going to get? The compound will be like this, my dear friends. See, this compound is this one. This OH is there, COOO is there, now CH3 is there, salicylate. This is known as methyl salicylate. Now see, kids, these two compounds, they are looking very close to each other, but that is aspirin, and this is known as oil of wintergreen. Remember that. What is this compound? Oil of wintergreen. This compound is oil of wintergreen. Remember that. This is oil of wintergreen. Some people call it iodex also. Now, this is very important reaction. This is very important compound. Kids, if you are able to understand, show me the thumbs up. Everyone, I want to see your thumbs up. If everyone is able to understand, show me the thumbs up, kids. Everyone, I want to see your thumbs up. Now, let's see the mechanism of this reaction. Let's see the mechanism. What questions can be asked from the mechanism of this reaction, my dear friends? Let's see. This is your chloroform CH, Cl, Cl, Cl. In front of this KOH will come OH negative, K positive. You know very well this OH negative is base. Base is always in search of H plus. So this H plus will go along with OH negative. So water will get eliminated out. Water has removed. You got C negative, Cl, Cl, Cl. Now this compound is stabilized by resonance. See why? This carbon is having extra electron and this chlorine is having 3p is filled with electron, but its 3d is vacant. 3d is empty. So this electron will get shifted over there. So this is known as 2p pi, 3d pi back bonding. Very good. 2p pi, 3d pi back bonding. Now this Cl will go along with K plus and Cl negative. Now right now this carbon was having 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. What it is going to lose 2 electrons. Now it will be having just 6 electrons, and this will be known as dichlorocarbene. Now see, my dear friends, it's looking like that it is having one lone pair, but it is just having 6 electrons in the valence shell. So it's only sextet is complete, but its octet is incomplete. Sextet is complete, but octet is incomplete. Octet is incomplete, my dear friends, incomplete. So this is electrophile dichlorocarbene. And examiner will ask you this question only, that who is the actual attacking agent. So you are supposed to write down dichlorocarbene is the electrophile who is responsible for Reimer-Tiemann reaction. Everyone, clear to all of you? Now, my dear friends, is it clear to each and everyone? Is everyone able to understand the Reimer-Tiemann reaction and the mechanism? Now, this dichlorocarbene will go and attack. See how it is going to attack. Just see to it, kids. This is your phenol. And you know that phenol is acidic in nature. So its equilibrium will lie more towards phenoxide side, because phenoxide is thermodynamically more stable. So now in the phenoxide, this electron will show movement, and due to plus m, that is plus r effect, the electron will come over here and this electron will get shifted toward this side, and you will get something, a thing like this. Now, my dear friends, just see, this carbon is having 8 electrons and it is acting as a nucleophile, and the dichlorocarbene, its carbon is acting as electrophile, that is CCl2. Everyone see to it. This is electrophile CCl2. So this is having just 6 electrons and this is having 8 electrons. So this carbon is saying, hey, my friend, my dear friend, carbon, we are just like brothers. I'm being carbon, you are being carbon, brother. So just give me 1 electron. Just give me your 1 electron. So this electron will be gained by that carbon. Now this carbon, after gaining 1 electron, will be having 7 electrons and 1 negative charge. And this, after losing 1 electron, its negative charge will go away. 7, 7, they will come together, and sharing is caring. They will have 8 electrons. And now let's see how they will look like, my dear friends. they will look like this. Double bond O, double bond, and this is right now the new bond has been formed in between carbon-carbon. Examiner will ask, in which reaction carbon-carbon new bond formation takes place? Aldol condensation, Claisen condensation, Wurtz reaction, yeah, and Reimer-Tiemann. Cannizzaro, no, Baba, no. In Cannizzaro, no new bond formation takes place. Now this is having negative charge, and this hydrogen is being allylic. Now it will shift by losing its electrons. It will shift towards this carbon, and how it will look like, just see to it, my dear friends. Now it will look like this. So negative charge over here, this double bond O and C, Cl2, and one hydrogen will come. So it will be like this. Can you understand, my dear friends? Now this electron will go back just to regain aromaticity. It will come over here. Now how it will look like, just see to it, my dear friends. It will be like this. This benzene, it has regained its aromaticity. Right now it was not aromatic, and CH, Cl, Cl. Now 2 KOH will come, KOH, K positive, OH negative, K positive, OH negative. 2 moles of KCl will eliminate out, and what will you get? You will get compound like this. CHOH, OH, and you know very well that 2 hydroxyl groups are not stable at 1 carbon, so water will get eliminated out. Now see, OH negative and this H positive water, so negative and positive, they will form product, that is your salicylaldehyde. In this way, this reaction got completed, and this is the detailed mechanism, my dear friends. Detailed mechanism of Reimer-Tiemann reaction. So they can ask up to here, my dear friends. Kids, is it clear to all of you? Now see, let me tell you another reaction. This is Kolbe's reaction. Right now you have seen that phenol got converted to salicylic acid and salicylaldehyde. Now see, in Kolbe's reaction, but remember that this is Kolbe's reaction, not Kolbe's electrolysis. That is another thing, Kolbe's electrolysis. This is just Kolbe's reaction. Now see what is going to happen over here, my dear friends. In this reaction, phenol will react with NaOH. It will form sodium phenoxide. Now the sodium phenoxide will react with carbon dioxide, temperature, pressure, and in this way you will get salicylic acid. Its mechanism is not that important. Just remember that here also you are going to get salicylic acid. What you got? Salicylic acid is the product. Let me write down over here once again. What is your product? Salicylic acid is the product. So if anyone is going to ask during Kolbe's reaction, what is your product? So salicylic acid is the product. So in this reaction, too much important, it's not that important, but if you want to see the mechanism, you can see carbon dioxide is like this, O delta negative, carbon delta positive, and just like dichlorocarbon, this carbon-carbon new bond formation will take place. Only this much. Yeah, but this reaction is given in your NCERT. So I'm going to give it 15 star. This reaction is very, very important, but you have to keep it in your brain, right? Now, next reaction. Next reaction, Kolbe's electrolysis. But before that, let me tell you the comparison of these two reactions. Just see to it. Comparison. So suppose if anyone is going to start with this phenol and they are writing like this, two reagents, one reagent is CCl4, KOH, you have to answer it immediately if you are able to understand. NaOH, carbon dioxide, high temperature and pressure, pressure. Just do let me know in both these reaction product will be same or different. Everyone do let me know in both of these reaction product will be same or that will be different. One is being RTR, you know, this is being RTR and this is being Kolbe. Everyone say Kolbe's reaction. So salicylic acid will be the answer. I hope that everyone is able to understand. All my dear friends, do let me know that everyone, yeah, it's same. Always participate. I want to see in the chat section whether you are participating, then only you are going to get the fruits. Otherwise, you will not. Now, see, my dear friends. Next reaction is Gattermann-Koch. Gattermann-Koch reaction. Now, see how arrange these names. These names are really very important, and this is given in NCERT. So 15 stars. 15 stars. Now what is this reaction? Benzene. And benzene when reacts with CO, HCl and catalyst, you will get salicylaldehyde or benzaldehyde, because this is just benzene, so you will get benzaldehyde. This is your Gattermann-Koch reaction. Now my dear friends, one more thing let me tell you. If this benzene is going to react with hydrogen cyanide plus HCl catalyst H3O plus, once again you will get benzaldehyde. Now you can see this and this common. For both the reactions, benzene is common, product is common, HCl is common. Just the difference is of what? Difference is of, my dear friends, CO and HCl. This is only the difference. You can see this is known as Gattermann-Koch and this is known as, yes, is there anyone who is going to tell me what this reaction is known as? Is there anyone who is going to tell me? This is known as Gattermann-aldehyde synthesis. Gattermann-aldehyde synthesis. Gattermann-aldehyde synthesis. That is Gattermann-Koch and this is Gattermann-aldehyde. Both of these two reactions, yes, very important. Don't get confused. Now, how to keep it in your brain? Gattermann-Koch, just focus over here. In co there is co, in co there is co. So this is Gattermann-Koch and this is Gattermann-aldehyde. This is the thing which you can keep in your memory, my dear friends. In this way you can keep rest of the things in your brain. Now let's come over here. Itard reaction. This is very important reaction. Is there anyone who is going to tell me what happens in Itard reaction? This is also given in NCERT. Itard reaction. Is there anyone who is going to tell me, my dear friends, what happens in Itard reaction? Very important thing, my dear friends. In this reaction there is benzene or toluene. Definitely there is toluene. Now this toluene is allowed to react with one compound which is reddish brown, that is CrO2, Cl2, you can say it is gas, chromyl chloride and carbon tetrachloride, CCl4. Then it will give you one intermediate. I will tell you that intermediate later on, but that intermediate on reaction with H3O plus is going to give you benzaldehyde. The product as benzaldehyde. Now my dear friend, this reaction is already given. This is chromyl chloride. Now this intermediate, once asked 2 or 3 years back, I have been teaching for the last 24 years and I was waiting, I kept on waiting that when the examiner is going to ask this intermediate. And 2-3 years back, yes, it was asked in the examination. Now see that intermediate, how to learn it and how to keep it in your brain. Now see CH I have written this much CH. Now, what I'm going to write? O, O, everyone say O, O, crow, 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 you know crow, black crow, O crow, O crow, HCl, HCl whole twice, O crow, HCl whole twice, O crow, HCl whole twice. This is intermediate of this reaction, intermediate which is formed during this reaction, highly unstable, and it will form benzaldehyde. Neither mechanism is important of this reaction, no other example is important. Only one example, that how will you convert toluene to benzaldehyde in single step. This is your toluene to benzaldehyde in single step. Always remember that this reaction is very important for examination. Kids, till now, are you able to keep? Kids, I have taken 3 sessions. I could have taken one session, one long marathon, but in that way, you won't be able to keep all the reactions in your brain. That's why I kept 3 sessions, so that you should get some time and it would be very easy for you to remember it, to digest it, my dear students. You liked my efforts. You don't know how much I'm going to think for all these things, that not only teaching is important, just to keep the things in your brain is also equally important. To think about my students, how they will digest these things, that is also really very important, all my dear students. So everyone, you have to help others also, my dear students, because God is there who's just watching each and everything, that who is helping others or not. So keep on sharing, keep on liking. Your Baba HSP is over here. Now see kids, next reaction, a Rosenmund reduction. Everyone say Mund of rose, Rosenmund. That's why I have written rose like this, rose, Rosenmund. Now let's see what is going to happen over here. In this, there is benzoyl chloride, benzoyl. Everyone say benzoyl chloride. They can give you like this, benzoyl chloride. They can give you like this, C6H5 COCl, benzoyl chloride. They can give you like this, PHCOCl, benzoyl chloride. They can give you like this, COCl, or they can simply write benzene carbonyl chloride, benzene carbonyl chloride, and its general name is benzoyl chloride. Everyone say, see the tongue twister, benzoyl chloride. Everyone say benzoyl chloride, benzoyl. Wherever you are seated, everyone say benzoyl chloride, benzoyl chloride. Now this benzoyl chloride, when it is going to react with H2PD barium sulfate charcoal. Do you remember this Lindlar's catalyst? You will get benzaldehyde. Why they are saying that this is reduction? How to find out this is reduction? Just apply physical chemistry to find out this is oxidation or reduction. Let me take another page to find out whether this is oxidation or reduction. Just see to it, everyone. If I say there is RCOCl, what is the oxidation state of carbon? Just see, this is donating electrons, so +1, because it is +1, so it is -1. This is -2, so this is +2. This is -1, more electronegative than this, more electronegative, so -1, +1, +1, -1 has cancelled out. You can see +1, -1 cancelled out. Its oxidation state has come out to be +2. Now see, this has converted into RCH double bond O, aldehyde. Now see, What is the oxidation state? This is donating electron +1 plus I -1. This is taking electron -2, so +2. Hydrogen is donating electrons, so +1 -1. -1 -1 -2 +2. It is 0. The oxidation state has come out to be 0. My dear friends, from +2 to 0, it has gained how many electrons? It has gained 2 electrons. So definitely this is undergoing reduction. So this is oxidizing agent, my dear friends. Examiner can apply physical chemistry redox reaction that it is undergoing reduction, the entity which is undergoing reduction. So definitely this is your oxidizing agent. Now is it clear to all of you? Now if examiner is going to ask 2 questions, just see to it. If examiner is going to ask 2 questions, whether you are able to give the answers or not. See, if examiner has asked this question, CH3 COCl, he can give you its name also. Its name is acetyl chloride. So remember, its name is acetyl chloride, or he can give you IUPAC name, that is ethanoyl chloride. Ethanoyl chloride. Now my dear friends, if this is allowed to react with H2PD barium sulfate, what will you get? So same number of carbon atoms, just remember, same number of carbon atoms, you will get aldehyde. So acetaldehyde is your answer. Is it okay, my dear students? Is it clear to all of you? Yes sir, we got it. Now if examiner is going to give you benzoyl chloride, oh my god, you have seen benzoyl chloride already. I have given benzoyl chloride, so it can be any RCOCl. Now my dear friend, what is the drawback of this reaction? Let's talk about the drawback. Drawback of this reaction is, my dear friends, just see to it. Let me tell you the drawback of this reaction or shortcoming of this reaction. Drawback or shortcoming of this reaction. Shortcoming of this reaction is that formaldehyde cannot be prepared by this reaction. Why formaldehyde can't be prepared by this reaction? This is the shortcoming, that formaldehyde can't be prepared by this reaction. Another shortcoming, but before that shortcoming, let me tell you the explanation why formaldehyde cannot be prepared by this reaction. Because HCOCl is not stable at room temperature, not stable at room temperature, so formaldehyde can't be prepared by this reaction. Another shortcoming of this reaction is, my dear friend, just see to it. Another shortcoming is that ketones cannot be prepared by this reaction. Ketones can't be prepared by this reaction. Ketones can't be prepared by this reaction. Now, my dear friends, in the NCERT, one thing is given, that ketones can be prepared from RCOCl, but that is not Rosenmund reaction. See, if you want to prepare ketone, that will not be known as Rosenmund reaction. What you're supposed to do, you take CH3 COCl and react it with dialkyl cadmium, that is R2CD. This is known as dialkyl cadmium. It is given in your NCERT, dialkyl cadmium. Now with water you will get R, C double bond O and R. So you got ketone. But this reaction is not Rosenmund. This reaction is not Rosenmund, because Rosenmund's limitation is that ketones cannot be prepared by a Rosenmund reaction. But from RCOCl, you can prepare, this is R, I have taken methyl as R, so it should be CH3, C double bond O, R. Right, my dear friends? This is given in NCERT. So this is the way that you can prepare ketone from the same thing, but this is not Rosenmund reaction. Now, my dear friends, next, just see if examiner is going to give you some reaction like this. CH3 CO Cl, once he has reacted it with H2 PD, barium sulfate and charcoal, and another time he has reacted with dialkyl cadmium and water. What products you are going to get, just do let me know in the chat section. So your answers should be, once being acetaldehyde, that is CH3 CHO, and another one will be CH3 CO CH3. This is aldehyde, this is ketone. Which one is Rosenmund? Which one is Rosenmund? This reaction is Rosenmund, but this one is not the Rosenmund. I hope that this much is clear to each and everyone. So let's have a glass of water. Let's have a glass of water. And my dear friends, you means a lot to me, and your success is my success. So we have to be very regular, and regularity doesn't mean that you are watching this lecture. Regularity means that you are paying attention, and paying attention means you are giving answers in the chat section. Answers I want to see, and later on, after completing all these reaction, I will frame out number of questions on this, right? Now, next reaction, Hell-Volhard-Zelinsky. Hell, you must have seen that number of people saying, I'm not saying go to hell. So Hell-Volhard-Zelinsky, you must be aware with this name Zelensky, the war of Russia and like that. Zelensky, Hell-Volhard-Zelinsky. So I have to give 15 star to this reaction because it is given in your NCERT. 15 star. 15 star means you have to keep this reaction always in your brain. That is very, very important. Those who are new, those who have not watched the first and second lecture of this reaction again, part 2, part means name reactions 1 and 2, then let me tell you, 15 star means this reaction is very, very important. So in this reaction, let us take example of CH3 COOH. Just try to understand. Attack will be on this R part. The attack is going to take place on this R part. With respect to this is alpha carbon, and this is having 3 alpha hydrogen atoms. Now, this reaction will take place with X2 red phosphorus, and this X can be either chloride or bromide, but not the fluoride and iodide. Just remember, this reaction is for either chlorine or bromine. X could be either chlorine or bromine. Now you are going to get product as CH2COOH and X. The X will be at this place. This is Hell-Volhard-Zelinsky reaction. In short, we can say HVZ. Hell-Volhard-Zelinsky. Suppose if you're not liking someone and somebody is irritating you, so you say, hey, Hell-Volhard-Zelinsky reaction, open-ear oxidation, Rosenmund reaction, Cannizzaro, Hofmann-Bromamide degradation. So what that person will feel, but you haven't said anything. Now see kids, this is monohalogenated carboxylic acid. Monohalogenated carboxylic acid. Now, if twice more you are doing the same, X2 red phosphorus, then what will you get? See to it. What are you going to get? CCl COOH. Yes, how many X should I write? How many X? 1X, 2X, 3X. Trihalogenated carboxylic acid. That means 2 times more HVZ has taken place, and you got trihalogenated. Trihalogenated. Clear to all of you, my dear friends? I hope that everyone is able to understand. Now, see, kids, this much is only important. No mechanism is required. Let me tell you, wherever I'm telling you mechanism is required, I have got 24 years of teaching experience. That means a lot. That holds a hell lot of weightage. This is the most important thing, where the mechanism is important and where the mechanism is not important. Where I'm telling you the mechanism, there it is important. Wherever I'm saying that mechanism is not required, that means mechanism is not required. This is the experience, my dear friends. Now, Dipali Verma, Viresh, welcome. Anush Tiwari, Anju Singh, Kriti Verma, wow, Karan Chawla, everyone is there. Very good, very good. I'm so happy to see you, my dear friends. I'm so happy to see you. Now, see, side chain oxidation, this is given in your NCERT, and I'm going to give you 15 stars. 15 stars. Just see, try to understand. I'm going to write down. If I write toluene, and if I'm going to react this toluene with reagent, that is K-amino4, KOH, heat, or a reagent K-amino4, acidic medium, or K2CR2O7, that is potassium dichromate, acidic medium, orange color, that is pink or purple color. Now, what product I am going to get? I will get benzoic acid. Benzoic acid. Just try to understand, kids. Everyone try to understand. Now, in place of toluene, if I am taking ethyl benzene, and I am reacting with the same reagent, then also I am getting the same product. Now, suppose if I am taking cumene, CH3, and I'm giving the same reagent, then also I'm getting the same product. Now, my dear friends, what you are able to understand, irrespective of the chain length, irrespective of the compound, just remember that this carbon, that is your alpha carbon. If alpha carbon is having at least one hydrogen, alpha carbon with at least one hydrogen, you will get always the product as benzoic acid. Whatever the chain length, my dear friends, if I increase the chain length from here to Switzerland, Sweden, Norway, Finland, wherever, from here to Tirumala, that is Trivandrum, I will get the same product. Just see to it, my dear friends. If I write down reaction like this, this is our reactant CH2, and whatever the chain length CH3, and if I am going to react it with potassium permanganate, KMNO4, KOH, heat, what product you will get, kids? Just you have to see, this carbon should have at least one benzylic hydrogen. The product will always be benzoic acid. Now, suppose if I give you this reactant, tertiary butyl, if I place over here tertiary butyl, what do you think? Your answer is going to be benzoic acid? No benzoic acid. Your answer will not be benzoic acid. No benzoic acid, my dear friend. Why no benzoic acid? Because this carbon is not having alpha hydrogen. There is no benzylic alpha hydrogen atom. That is the reason. That's why you haven't got benzoic acid. Now, my dear friends, everyone see to it. If I give you one reaction like this, this is xylene. Suppose if I give you, this is being xylene. This is CH3, this is CH3, this is orthoxylene, and I'm reacting it with KMNO4 acidic medium. What do you think? What product you will get? KMNO4 acidic medium. So definitely your answer will be both the COH will, both the methyl will convert into COH, and this compound is known as halic acid. Halic acid. Halic acid. Now, my dear students, there is one very, very interesting thing, that if I treat this compound, CH3, CH3, CH2, CH2, CH3, what do you think? If I apply the same reagent, I will get phthalic acid, yes or no? Will I get phthalic acid? Will I get phthalic acid? Yes. Irrespective of the chain length, irrespective of the alkyl group, irrespective of chain length or alkyl group, we will always get benzoic acid. This is really the thing, that alkyl group will change to COH. Now, Kolbe's electrolysis, my dear friends, this is really very, very important reaction. One reaction I have told you, Kolbe's, their phenol got converted to benzoic acid. Now I am going to tell you Kolbe's electrolysis, and this reaction is very, very important, my dear students. If you see NCERT of class 12 part 2, it's written that this reaction is very, very important, but this reaction is missing over there. NCERT writes in between the line, so we have to catch that thing, whatever is missing. But NCERT has given in some on some page that, yeah, this reaction is important, but reaction is missing over there. Now see, my dear friends, are you ready? First, should I tell you this reaction's short trick should I tell you, or should I tell you the detail? I have to tell you both the things. In detail also I am going to tell you this reaction, and the short trick also I will let you know. But first, what you want, the trick or the detail mechanism? First, from which, what should I start, with the trick or the detailed? What do you want first? Dipali, Akanksha, Krishna, everyone do let me know. Shramardhi, trick, detailed, short. So first I am going to tell you the trick. See, the trick. First, let me tell you, this reaction is used for preparation of what? This reaction is used for preparation of alkane, as well as this reaction is used for the preparation of alkyne. All three, alkane, alkene, alkyne means, if I talk about your hydrocarbon, that alkane, alkene, alkyne, all three can be prepared by this reaction. Just see to it, my dear students, what I am writing and what I am telling you. All three can be prepared. Alkane can be prepared, alkene can be prepared, alkyne can also be prepared by this reaction. All three types can be prepared. Now let me tell you the short trick. Just see to it, everyone see to it. Kolbe's electrolysis short trick. Now let me take R, C double bond O, O, Na. In place of sodium, you can also take potassium. One more mole of R, C double bond O, O, Na, and it's aqueous solution. Aqueous solution means water. HO, H, HO, H, and we have to supply current. That is I for current. Now see the short trick, HSP Baba short trick. What you are supposed to do, my dear friend, this is R. Now what you are supposed to do, see to it that 2R will come together This CO2 will eliminate out, my dear friends. CO2 will eliminate out. This CO2 will eliminate out. Both the CO2s will eliminate out. Just see to it. Now, these two things are going to get formed at anode. Anode, just keep in your brain that they are going to form at anode. This RR will form alkane gas, 2 moles of carbon dioxide. So, 2 moles of carbon dioxide. So, total 3 moles of gas, 3 gaseous moles you have got at an anode. At anode. These 3 gaseous moles you have got at anode. Now, what you are going to get at cathode, this H plus and H plus, hydrogen gas, H2 gas at cathode, this at anode 3 gaseous moles. Now 1 gaseous moles at cathode, 1 gaseous mole. So 3 raised to 1. Now what you are going to get in the solution? In the solution, you will get NaOH. What are you going to add in the solution? NaOH. This NaOH is indicating in the solution that this medium is being basic. So pH of the solution will keep on increasing. This is in solution. Anode, solution, cathode. Are you able to understand? Anode, solution, cathode. If you want to take, thank you Samriddhi, thank you. This is the short trick. If you want to take screenshot, you can have it. Then I'm going to tell you each and everything. Yes, Keshwani, thank you. Wow, that's really awesome, students. I want to see your likes. Now, my dear students, let me give you one question on the basis of that. Let's see whether you are able to do that question or not. See to it. Everyone, see to it. Suppose if we are provided like this CH3, CH2, COOK aqueous. Examiner has given you this question, my dear friends. Examiner has given you this question, how to do it. This is your question given by examiner, how to do this question. Now let's see, my dear friends. Its answer will be like this. You have to apply short trick, CH3, CH2, COOK, 1 more mole, CH3, CH2. You have to become very fast, super fast right now only. And water, that water is HOH, HOH. Now you can see very clearly what you are going to get. Just see to it. It will break from here. And this will combine together. This will try to form a bond and you will get butane, CH3, CH2, CH3, 1 mole of butane plus 2 moles of carbon dioxide. These 3 gaseous moles you will get at anode. Now in the solution you will get 2 moles of KOH in the solution, so they will increase the pH of the solution, and at cathode you will get 1 mole of hydrogen gas. Everyone is able to understand, my dear students? Do let me know. Is this answer I have written or you have written? Yes, everyone able to understand, my dear friend? Do let me know. This is clear to each and everyone. Say yes, yes, yes. Everyone, if you have become expert in this, then only it is going to help you, my dear friends. Everyone write down yes. I want to see your thumbs up along with yes. If everyone is able to understand, my dear friends, I want to see your thumbs up yes, or hearts yes. Heart yes, thumbs up yes. Now let me tell you the alkene preparation. Just see to it. Alkene preparation. Let's see the alkene preparation. Now see, just focus on alkene preparation. CH2, CH2, C double bond O, O, Na, C double bond O, O, Na. Now you know the name of this compound. I've told you Ohm's gap. Number of times I have given you the trick. Ohm's gap. Dicarboxylic acid with 2 carbon extra, CH2 extra. So it is succinic acid and its name is sodium succinate. Examiner can give you the name also. Sodium succinate. Sodium succinate aqueous solution. So aqueous solution HOH, HOH. Now the electrolysis started. How to do this question? See to it, everyone, see to it. Just break the bond from here. This bond will break and this will try to form new bond. So what you are going to get? Just see to it. You will get CH2 double bond CH2, 2 moles of carbon dioxide. This is at anode. This you are getting at anode. In the solution you are getting 2 moles of NaOH. The pH will keep on increasing, and at cathode you are getting hydrogen gas at cathode. Is it clear to all of you? I hope that everyone is able to understand. Now, in place of this, if examiner has given you one tough question, just see to it. Yeah, I can see your answer, everyone's answer. That's really fantastic. Now I can see everyone has started writing answers. That's really fantastic. Now see, my dear student, suppose if examiner has given you a little bit tough question like this, that CH, CH3, CH, CH3, C double bond O, OK, C double bond O, OK, aqueous solution. Now, my dear students, is it possible to do this question? So everyone, what you're supposed to do, just apply my trick and you will get the answer. How to do it? Now see, once again you have to do the same thing. Break the bond from here. Break the bond from here. This bond will start breaking up and you will get. Now see what you are going to get. CH double bond CH. The CH3 over here. The CH3 over here. Now 2 moles of carbon dioxide. This much you will get at anode. Now 2 moles of KOH in this solution and hydrogen gas at cathode. Everyone, just do let me know. But2 will be the answer. Everyone clear with this? Do let me know that everyone is able to understand, my dear students. Everyone is able to understand. Now, this was the alkene preparation. Now, let's see the alkyne preparation, my dear students. Let's see the alkyne preparation. Now, suppose examiner has given you compound like this, CH double bond CH, COONA, COONA. This is known as sodium malate. Sodium malate, my dear friend, sodium malate, aqueous solution, and the electrolysis that is being current. Now, my dear friend, I hope that now you have become intelligent. You can write down product by yourself. What you're supposed to do? Break the bond from here. Break the bond from here, and they will form extra bond. 2 bonds are already there. 1 more bond. So what you are going to get? CH triple bond CH. Already 2 bonds, 1 bond extra, acetylene, plus 2 moles of carbon dioxide. This much is at anode, plus 2 moles of NaOH aqueous solution and hydrogen gas at cathode. I hope that everyone is well aware of this reaction. Now, my dear student, I can see some students are responding, not all these students, but yeah, that's really awesome that some students are responding. Now, once the question has been asked in AIMS examination, to do such type of tough questions, we need the mechanism. We have to understand the mechanism. Just see, I'm going to deal with the mechanism. Suppose they have given you this reaction, CH3. Let me take one example, CH2 COONA aqueous. Now you know that to do electrolysis, electrolytic tank is required. Electrolytic tank is required. So let's take one electrolytic tank, my dear friends. Let's take one electrolytic tank. This is your electrolytic tank. This is electrolytic tank. Let's take anode and cathode. Let's form the anode and cathode. How will you find out which one is anode, which one is cathode? For that, you know that the one which is attached with positive terminal of the battery will be anode, and the one which is attached with negative terminal of the battery will be your cathode. This is anode and this is cathode. Anode, the positive terminal of the battery, cathode, the negative terminal of the battery. Do not get confused with electrolysis and electrochemical cell. In electrochemical cell, the anode is undergoing oxidation. From there, electron is generated. That's why this is negative terminal in the electrochemical cell. And cathode is being, yes, positive terminal. But in electrochemistry, yeah, if you're dealing with electrolysis, the anode will be the one who is attached with positive terminal of the battery, and cathode will be one which is attached with negative terminal. But in both the reaction, one thing is being common, that always at anode oxidation takes place. At anode always oxidation takes place, whatever the type of cell. And at cathode always reduction takes place. At cathode always reduction takes place. This is, now let's take electrolytic solution. This electrolytic solution, what I am going to take, see kids, this is negative. So CH3, CH2, CH3, CH2, COO negative is anion, and in the water, so OH negative is anion. Two anions we have got. Anions we have got, two anions we have got, and cation, that Na plus cation and H plus cation. Two types of cations we have got, two types of anions, two types of cations. Now when the electrolysis is going to get started, that's really fantastic, Shivakumar. When we are going to deal with electrolysis, then the anions, they are having negative charge. Anions will start moving towards anode. Anions will go towards anode, and cations, they will move towards cathode. Positive towards negative and negative towards positive. Now, going is one thing. Oxidation of only that entity is possible which is having more preference to undergo oxidation, and reduction of only that entity is going to take place which has got more potential to undergo reduction. That means standard reduction potential is more. Now see, out of these two entities, this will undergo oxidation. Its preference is more towards oxidation. So let's see, if I take one molecule CH3, CH2, C double bond O, O negative, and if it is losing electron, it will turn out to be like this: CH3, CH2, C double bond O, O. One electron has been lost. Oxidation has taken place. Now if I say, if I am going to take 2 moles of it, 2, then 2, and 2 electrons will be lost, then also oxidation. Oxidation. Now you know that carbon dioxide is very good leaving group. So carbon dioxide will try to eliminate out. So what you are having, that you are having 2 moles of CH3, CH2 free radicals, and 2 moles of carbon dioxide has eliminated out. Is it clear to all of you? Till now, is it clear? Now these 2 electrons will be accepted by H plus. You know that electrochemical series, H plus have more standard reduction potential value as compared to Na plus. If you see, Na plus is not going to accept electron because Na has lost electron. Na has undergoing oxidation. Na has undergone oxidation to give Na plus. Why Na plus is going to accept electron? Na plus is not going to accept electron. H plus will accept 2 electrons. So it is undergoing reduction. It will form twice of H. Nascent oxygen will form hydrogen gas. Now, let's see how they are going to combine. I hope that this much is clear to all of you. Till now, all the points are being clear. Now, next page, how this ethyl free radical is going to combine. Number of things they are moving in the electrolytic tank. Number of things they are moving in the electrolytic tank. So, let me draw once again the same electrolytic tank over here. Now, in this electrolytic tank, who is moving? There is CH3, CH2, C double bond O free radicals. Some of these free radicals. Some of these free radicals are there, CH3, CH2 free radicals. Such type of free radicals are there. If by chance they are going to combine together, what they will form, kids? They will form, yes, they will form CH3, CH2, C double bond O, OC2H5, ester, my dear friends. Now, this ester is formed but in negligible amount, but yes, it is formed. This was asked in the AIMS examination, ester in negligible amount or in traces, we can say in traces, but yes, it will get formed in traces, but yeah, it will get formed. Now, this ethyl free radical, you know very well, number of times I have told you that ethyl free radical can combine like this. Two ethyl free radicals will combine like this to form butane. This is the major product, C4H10. Butane, this is being major, my dear friends, right? This one is major, but this can also undergo disproportionation. This thing I've told you or not, that it can undergo disproportionation reaction. If this is undergoing disproportionation, so you will get ethene, also one of the product, plus ethane. Now, this is also formed in negligible amount, but yeah, it is formed. An examiner can ask you this also. So this is the detailed mechanism, my dear friends. Are you getting it? Let's have a glass of water, then we will move towards another reaction and just see to it. This can be asked. If tough question is going to be asked in the examination, then they can ask such type of things, my dear friends. How many of you are liking it, the short trick and the detailed mechanism I have told you? Show me the thumbs up. And my dear friend, those who have not smashed the like button, hit the like button right now. I want to see, my dear friends. That is the most important thing. My dear friends, my best efforts I have added. You see, the names are already written so that I should not miss even by chance any name reaction. Because if your teacher is going to miss even a single reaction, you will lose marks. So see how much care I have taken, that I have written the names. Now, after this, same, which reaction? Wurtz reaction. You must have heard the name Wurtz-Khalifa. But Wurtz-Khalifa is, you can see right now, the present time they have built that Wurtz-Khalifa, but this reaction is very, very famous, and this reaction, Wurtz reaction, see to it everyone, what is Wurtz reaction? Let's see, hey, come on everyone, Wurtz reaction. That in the starting, I have seen like this, Rx, it was in my school time, what I was going to learn, Rx, twice of Na, what's written like this, Rx plus twice of Na, and then here on the arrow it was written dry ether, and that was forming RR plus NaX. I still remember those school days. Only this much I was able to learn. Even only this much I was able to learn, that this is Wurtz reaction. Now, my teacher told me that over here, just see kids, this is symmetrical alkane. Oh, yes, sir. Symmetrical alkane. So we kept this thing in our brain and we were doing questions. See how the questions we were doing. Sir was giving us like this. Methyl chloride Na dry ether. So we were writing right there's twice of Na, chloride, methyl. Then we were taking scale. We were taking a scale and we were just drawing it like this. Oh, secret. In my school days, I was doing like this. Even you would have done this. Now, this must be forming CH3, CH3, twice of NaCl. Now, that's really fantastic. But my teacher told me this Rx, either it can be 1 degree or 2 degree, but can't be 3 degree. This can't be 3 degree. Okay, sir. Okay, sir. Now, if teacher is going to give you a question like this, isopropyl chloride, CH3, CH, CH3, Cl. Now, twice of Na, Cl, CH, CH3, CH3. How to do this reaction? Yes, sir, I know very well what to do. Yeah, my dear students, you know the trick. You know the drill. That CH3, CH, CH3, CH, CH3, CH3, 2,3-dimethyl butane. You got it easily. You got it easily. But remember that. Wow, Kriti Verma from Kashmir. That's really fantastic. Now, my dear students, 3 degree, if you're taking 3 degree, that it will undergo elimination. That's why 3 degree alkyl halides are not used during this reaction because their activation energy is very high. They won't be able to give this alkane. Now, question arises how to get this product. But before that, let me tell you some more reactions so that easily you can understand it, my dear friend. Just see to it. If your examiner is going to give you a question like this, your examiner has given a question like this, that this is the compound, this is the reactant, here Cl and here Cl, just try to focus, and twice of Na dry ether. What are you going to get, my dear friends? What will you get? Just see to it. This chlorine and this chlorine will go away and the product will be like this. Now already this bond is there, this bond is there, this bond is there. These 3 bonds were already present. One more new bond will get formed and this is this bond. The answer is being cuvane. Yeah, that's really fantastic. I can see. Yes, that's really fantastic. Now, my dear students, Wurtz reaction holds a hell lot of weightage. It follows 2 types of mechanism. One is being ionic mechanism, another one is being free radical mechanism. But before that, one question is really very important, that why Wurtz reaction is not suitable for preparation of unsymmetrical alkane. That is very important question, my dear friends. So the question is, why Wurtz reaction is not suitable for preparation of unsymmetrical alkane? Suppose if you want to prepare, your target is propane. This is the target. Somebody has given you, you are having industry of Wurtz reaction and somebody is asking to prepare propane. What will you do? Which alkyl halides will you take to prepare this propane? So definitely you will take methyl chloride, number of molecules, ethyl chloride, number of molecules. Now you will add them and you will carry out Wurtz reaction. Now, my dear students, you are going to try it. What problem will be there? Just see to it. When they are combining together, you will get propane, but it will combine with itself to give ethane, C2H6. It will combine with itself to give butane, And when both of them are combining together, they will get propane. And my dear student, all three are being gaseous mixture. All three of them being gaseous. Now, my dear students, it's very, very tough to separate gaseous molecules. You must have seen during corona pandemic that oxygen cylinders were not available in adequate amount, and the people were charging too much money if they were available. Now you know that in the air there is oxygen, there is nitrogen. If it was easy, if it would have been easy, then people must have separated out oxygen from the nitrogen, that is from the air. We must have inhaled oxygen only. But you know that it's very, very tough to separate out gaseous mixture, and that's why this is not economical. It's very, very difficult. It's very, very difficult to separate out gaseous mixture, to separate gaseous mixture. I hope that everyone you got it, all my dear friends. That's why it's not economical, or it's not suitable, or it's not feasible, and that's why odd carbon alkane, or we can say unsymmetrical or asymmetric alkane is not prepared. This is the reason why asymmetrical alkane is not prepared by this reaction. Everyone, if you are able to understand, show me the thumbs up or the hearts. I cannot see the hearts in the chat section, my dear friends. What are you doing? You got bored? Even the likes, only 55 likes are there. What are you doing, kids? Hey, everyone, just increase the number of likes. What are you doing? Yeah, now I can see. Yeah, that's my students. That's my students. Now, let's see the mechanism of Wurtz reaction. Oh, Fittig has come, but before that, let me show you the mechanism. Wurtz reaction follows both type of mechanism. Ionic as well as free radical mechanism. Both two type of mechanism this Wurtz reaction follows, my dear friends. Suppose if I say ionic mechanism, if I talk about ionic mechanism, then you can see, let's suppose one reaction, that is CH3, CH2, Cl. This is going Wurtz reaction, Na and dry ether, that is polar aprotic solvent. Now see, if I say that CH3, CH2, this bond is being polar, delta negative, delta positive. So this carbon will lose electron and it will form carbocation, CH3, CH2 plus. Now there is sodium, and you know that sodium is very good reducing agent. Sodium will oxidize. Malar Vanan from Tamil Nadu. Wow, yellow heart, that's really fantastic. Now, so let's suppose that sodium has donated 2 electrons, because number of sodiums are there, number of electrons will be there, and it can accept just 2 electrons, so it will change to carbanion. It has changed to carbanion. So one more molecule of ethyl chloride, some ethyl chloride must have converted to carbocation also. So it has lost this and it has converted to carbocation. Now you can see this carbocation, that carbanion, carbon-carbon new bond formation will take place, and examiner will definitely ask that carbon-carbon new bond formation. So you will get butane. But how do scientists, they have come to know that it is going to follow free radical mechanism also? Dear students, they are not able to understand the path so easily. but whenever they are going to carry out reactions, some type of products they have been formed, which they have indicated, this product formation have indicated that some more path must be followed, because during this reaction ethene gas has been released, but during this path you can see no ethylene gas has been formed. That means this reaction must have followed some other path also, some other mechanism also. Now see, my dear students, let's see the free radical mechanism of it. Let's see the free radical mechanism of it. Everyone try to understand the free radical mechanism of it. The free radical mechanism, just see. Same reactant I am going to take, CH3, CH2, Cl. Now, definitely once again I will write Cl is being delta negative and this is being delta positive. It has taken electron and it has been converted into CH3, CH2 plus. Now, it's not necessary that only one carbon can take 2 electrons. It could be possible that 2 molecules of it. This is also permutation and combination, that this is also carbocation and sodium has donated electrons, suppose twice of sodium. So sodium has given 1 sodium 1 electron, 2 sodium 2 electrons. So 1 electron, and sodium can donate electron, that electron can be taken by this also. So if this is going to absorb this electron and this is going to absorb this electron, both will convert into free radical. Earlier what has happened, that same thing is happening, that one alkyl can take 2 electrons, one will form carbanion, another one with carbocation, they can form the bond. But it is also possible that both the alkyls, they are going to take 1 electron, so they have formed what? You can see they have formed CH3, CH2. Now I have told you that 2 types of combinations are being possible, that these 2 molecules, if they are combining together, they will form butane gas. Butane, okay, this is your major product. Fantastic, we know very well this is major, but this can also undergo disproportionation reaction. Disproportionation means carbon is losing electron as well as carbon is gaining electron. So disproportionation, in this way you will get CH2 double bond CH2, although this is in major or minor amount, that is in traces, but yeah, this has given the clue for free radical mechanism, my dear students. Thank you, Echoes. My pronunciation is correct. Echoes. Tough name to recall, to pronounce it, it's really tough. Echoes. Now, my dear students, this is Wurtz reaction. Now, let's talk about Fittig reaction. The same thing, if we carry out in the aromatic case, if we take aromatic alkyl halide like this, twice of Na and dry ether, the same thing is going to take place with aryl halides. So definitely you will get biphenyl, you are going to get biphenyl, and this is known as Fittig reaction. Now, my dear friends, both got famous, both have become famous. Malar and Wurtz have become famous, Fittig has become famous. Both of them said, let's have party. So there was get together, and its name is Palak. Welcome. Wurtz-Fittig reaction. Oh, Frankland has come. Let me tell you, Wurtz-Fittig reaction. Wurtz-Fittig reaction. The get-together's name has been given as Wurtz-Fittig reaction. Wurtz-Fittig reaction. Both have become famous. Wurtz, aliphatic, Fittig, aromatic. So he has taken aliphatic one, he has taken aromatic one, and both combined together. Now kids, you will say, sir, this is aryl halide. How the reaction is possible? Kids, sodium is very reactive, and that's why due to sodium, because of the presence of sodium, this reaction is feasible. Dry ether. So what will you get? One aromatic, one aliphatic. So toluene or alkyl benzene is the product. I hope that everyone is able to understand this get together pathway. Let's have pathway tonight. So this toluene has been formed. This is Wurtz-Fittig reaction. Now, my dear friends, sodium is highly reactive and sometimes explosion has taken place, and due to this explosion, number of workers, they have died. So scientists thought that it's not good to use sodium always, because sodium is very reactive. Even when sodium comes in contact with cold water, then it is going to show vigorous reaction, my dear friends. So they thought not to use sodium. So there was one scientist named as Frankland. So what Frankland has done, my dear friend, Frankland has not used sodium. He has said that let's take Rx and I will use zinc as the reactant. So you will get RR ZnX2. So reaction is not that much vigorous. So for example, if we are going to take 2 moles of methyl chloride plus Zn, so Frankland reaction will take place. We will get CH3 and ZnCl2. So this reaction is comparatively less reactive, and this way you're going to get the product. Now, my dear friend, zinc is also, whenever it is going to come in contact with water, it is reacting. So one scientist was there, and that is Ullmann. He has used copper. Copper is used by Ullmann. Ullmann used copper, and how he has carried out its reaction, he has taken phenyl iodide, because iodine is very good leaving group, phenyl iodide, and he has used copper. You know that copper, whenever it's going to come in contact with water, nothing is going to happen to the copper. And what he has said, that let's have heat, we are going to heat, and now there is no explosion, there is no anything useless, and you're going to get same product and CuI2. So this is Ullmann reaction. But my dear friends, you must have noticed one thing, that everyone, whatever they have prepared symmetrical alkane. There was one scientist known as Corey-House. Let me see, Corey-House. This Corey-House reaction is used for the preparation of both the symmetrical alkane as well as the unsymmetrical alkane. And this is a very interesting thing, that this Corey-House is used for symmetrical as well as asymmetrical alkane. Both type of alkanes can be prepared. Now let's see what Corey-House has done. Twice of Rx, let me tell you, it is having just 5 stars, not the 15 star, not that much important, even it is not given in NCERT. Twice of Rx, and what they have used Li iodide plus Cu2I. So it has converted to R2 CuLi. This is known as Gilman's reagent. Gilman's reagent, my dear friends. You must have heard number of man: Spider-Man, Batman, in India Hanuman, Gurdas Man, Gandhiji's talisman. But this is Gilman, looking like something related to fish, but it is reagent, and it is intermediate, you can say, highly reactive. When this highly reactive intermediate is coming in contact with C, whenever it's coming in contact with Rx, Rx, this white R, this green R, so they will form symmetrical alkane. Symmetrical alkane. When it is going to come in contact with R dash X, they are having different R and R, so you will get asymmetrical alkane R and R dash. You can see very clearly this is symmetrical and this is asymmetric, and Corey-House reaction is used for the preparation of both symmetrical as well as asymmetrical alkane. My dear friends, are you able to understand till now? Now let's see the another reaction, that is soda lime 15 star, because this is very important. Soda lime's another name also I am going to tell you, but before that, everyone, I want to see, hit the like button, smash the like button, attendance to be marked, my dear friend. If you are having water, if you're not having water, then get it. Just have a glass of water, keep yourself hydrated. Doing smart study means do smart study. Smart study means doesn't mean get away from water, food, exercise. Along with food, exercise, adequate amount of sleep, the balanced diet and thinking. Just listen to music also whenever you're getting time. That is acting as the catalyst, my dear friends. Decarboxylation. Yes. Now, soda lime reactions, another name for soda lime reaction. Yes, my dear friends. Is there anyone who is going to tell me another name for soda lime reaction? Yes, my dear friend. Is there anyone who is going to tell me the another name for soda lime reaction? Its another name is decarboxylation. Decarboxylation. Or this is also known as lab method preparation of alkane. Lab method preparation of alkane. And my dear friends, let me tell you one most important thing that is really very important. I am going to tell you, just focus what I am going to tell you, my dear friends. In this reaction, there is shortening of the chain. The alkane you will get will be having one carbon less than the parent acid. This is shortening of the chain, just like happy birthday reaction. Shortening of the chain is there. Shortening of chain. That means alkane will be having one carbon less. Alkane obtained is having one carbon less. So whenever your teacher is going to ask, just prepare an alkane with one carbon less, so you can use this reaction, or Hofmann-bromamide degradation reaction. Okay, one more type of reaction I will let you know after soda lime reaction. Okay, Hunsdiecker reaction, that Birnbaum Simonini, but they are very less reactant, but before that you have to wait. Okay, let's see what this reaction is. What this reaction is going to tell you all about, my dear friend. Just see to it. And this is very important reaction. So let's see to it. 15 star and very important reaction, my dear friend. See to it. That if you're provided with R C double bond O OH, what everything is going to take place, let me tell you. There is caustic soda which is used, there is calcium oxide which is used. I will let you know about calcium oxide and caustic soda also, the chemistry of these two. But before that, let me tell you what is going to happen over here. So the CO2 will get eliminated out. See, this carbon is bonded with this, because this will go like this. this proton and this carbon ion. You can see very clearly, because whenever we are going to deal with the mechanism, you will get lost from this mechanism and you won't be able to understand. Just see what is happening, kids. This CO2 is eliminated out. This is delta positive, this is delta negative. CO2 will get eliminated out and this H and R will combine to give you RH. This is the whole thing, my dear student. First of all, everyone try to understand what I am going to tell you. This is the shortest thing that you are going to understand, but I will tell you in the detailed mechanism. This is R negative, and R negative which is formed during this reaction, that is your carbon ion. During this reaction, this carbon ion is the intermediate, and this thing you have to keep it in your brain, that carbon ion is the intermediate. Now my dear student, the carbon ion is the intermediate, so the rate of reaction will be dependent on, everyone do let me know, rate of reaction, rate of this soda lime reaction will be directly proportional to the stability of carbon ion. So remember that rate of decarboxylation reaction is directly proportional to the stability of carbon ion. Stability of carbon ion. Now, before going ahead, let's do some examples so that you can understand, my dear students. Hey, everyone, ready? Do let me know that how's the Josh. First of all, I want to see the Josh in the chat section, and at least make it 70 likes. My dear student, what are you doing? Likes are just 62. Try to make it 70. What are you doing, kids? Now, let's see. So here is the reaction provided to you, and let's try to understand and let's give the answer, my dear friends. Everyone, let's see to it. CH3, see what happened? Okay, CH3, COOH, NaOH, calcium oxide. It can be given like this. It can be even given like this. See, CH3, COONA, NaOH, calcium oxide. I will let you know each and everything in detail, but first of all, the answer will be same in both of these two cases. What should be the answer? Carbon dioxide will get eliminated out and your answer will be marsh gas, that is methane, plus Na2CO3. Now, how this reaction must have taken place, see to it. This is your CH3COH journey starts from here. This one reaction with NaOH acid base reaction will take place. It will form CH3 COONA, and then with NaOH and calcium oxide, the reaction which is going to take place, that is your methane plus sodium carbonate Na2CO3. Now, this NaOH is deliquescent. Deliquescent, you understand? Deliquescent. Deliquescent means which absorbs moisture from the atmosphere and gets dissolved in that, means loses their identity. And calcium oxide is hygroscopic. This is also water loving. Deliquescent is also water loving. Hygroscopic is also water loving. Both are water loving, but deliquescent gets dissolved inside the water, but hygroscopic do not get dissolved. They absorb moisture and retain their identity. One is losing its identity, another one. So that calcium oxide is the catalyst. Now see, my dear student. If somebody is going to give you a question like this, the question is provided like this: either benzoic acid or sodium benzoate is given, and if you are doing the soda lime reaction of them, soda lime reaction, what you are going to get, my dear students? Just to let me know. you are dealing with soda lime reaction, definitely your answer will be benzene. Your answer will be benzene. If you're going to use salicylic acid, suppose the reaction given is like this. Somebody has given you this reaction that phenol CCl4 KOH has given A. Now that A has been treated with NaOH excess, whether excess is marked or not, doesn't matter, calcium oxide. Now B is the answer. What is B? Let's find out what is B. Let's see whether you are able to understand or not. I have told you that I will keep on telling you each and everything, and when the time is going to come, I will ask questions also. Now see what is B. Let me see in the chat section who is going to give the answer properly. What is B? Gets just to let me know what is B. I want to see what is B. So you're taking too much time to give the answer. So that's why I have told you in the starting only, my dear friends, everyone, if you are doing it clearly, if you're making your efforts properly, just I want to see the answer in the chat section. Phenol, Samriya is saying phenol, and let me check it out. Jinendra is saying phenol. Wow, Jinendra is there, Samriya is there, Akanksha is there. Wow. Now, my dear friends, definitely this is RTR reaction. Your answer, I think, is absolutely correct. This is RTR reaction. So you will get salicylic acid, and the decarboxylation reaction will take place. So phenol is the correct answer. So congratulations to all my dear friends, those who have shown stupendous performance, are really feeling accomplished. Now see kids, let me tell you, if question is like this, my dear friend, just see to it. If the examiner has asked this question, just see to it, everyone. Very, very important question I'm going to tell you. So just see to it, everyone. If they have asked this question, arrange the following in decreasing order of rate. Arrange the following. Question is, arrange the following in decreasing order of decarboxylation. So we are provided with compounds like A, CH3, 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 COOH, B, CH3, CH, CH3, COOH, C, CH3, COOH, and D, CH3, C double bond O, CH2, COOH. These are the four options, A, B, C, and D. So I want to see, my dear students, what answer you're going to give. Who is having maximum rate of decarboxylation? Your Baba HSP is waiting for your answer. A, B, C, D. Jyoti is writing A, B, C, D, and Jinendra is writing D, C, B, A. D, C, B, A. So DCBA, Priyanka is also writing. So answer, Jinendra, Priyanka, your answer is absolutely correct, my dear friends. I've told you the rate of reaction is directly proportional to stability of carbon, and this point you have to keep it in your brain, my dear friends. Everyone, you are supposed to keep this point in your brain, that this carbanion you can see is stabilized by resonance. This is the only carbanion which is stabilized by resonance. And see one more thing, this is carboxylic acid and this is alpha carbon, this is beta carbon. So this is the identity of this type of compound. Whenever you are provided with beta keto acid, this is known as beta keto acid. So remember that. Beta keto acid, even they don't require NaOH calcium oxide. Simply on heating, I will let you know. I will write down one note for this. So now see, this is 1 degree carbanion. This is 2 degree carbanion. And this is being 3 degree carbanion. So first one who is most stable, stabilized by resonance carbanion, then 1 degree, then 2 degree, and then 3 degree. This is the stability of carbanion, my dear student. If this point is clear to all of you, do let me know. And if this point is clear to all of you, your answer is in your hands. That answer is being TCBA. TCBA. This is the answer, right, to all of you? Hey, my dear friends. Everyone got it? Do let me know, my dear friends. Now, I'm going to tell you the note. What I'm talking about, the note. The note is very, very important note, my dear friends. Note is beta keto acids undergoes decarboxylation. Undergoes decarboxylation. Simply on heating. Simply on heating. So take care of this, otherwise you will lose marks. So if anyone is going to give you a question like this is your reactant, and simply they have heated. Simply they have heated. What you are going to get the answer? Now see to it that this is acid, this is alpha carbon, this is beta, and this is also beta hydroxy. So it's not beta keto acid, nothing you are going to get. But they are going to replace it and they are going to write down like this. Now this is beta keto acid. So decarboxylation should take place like this. And here negative charge and this positive, they will form a bond. Cyclohexanone will be the answer. And once what they did, they asked one question based on this. And number of students, they lost their marks. See, the things will not be coming to your brain, and then everywhere the darkness will be there if you're not paying attention to it. Let me tell you what question they have asked, my dear friends. The question they have asked was like this. Brilliant question I'm going to tell you, my dear friend. The question they have given like this: CH3, C double bond O, OC2H5, and they have reacted it with C2H5ONA, that is sodium ethoxide, that has given A, and A was treated with water, that is hydrolysis, it has given B. The B was heated, just heated. Now let's see, are you able to remind it? C, they have asked about C. What is C? What is C, kids? So I'm giving you 1 minute, just try to understand, because if you are able to recall it, you will be definitely going to give the answer. And if you are not able to recall it, then you will lose it. Let's see, kids. Is everyone able to understand it or not? So what is C? I'm waiting for your answer. Everyone, do let me know. Ethane, Jyoti. Everyone, I want to see your answer, my dear friends. Let's see how many of you are able to give the answer. Ethanol. Jyoti is writing ethanol. Rest of others, I want to see your answer, my dear friends. What answer you are going to give, my dear friends? I want to see your answer. Let's see what answer you are going to get. Yes, my dear friends. Only Jyoti till now. Acetone. Samria, your answer is yes, correct. Absolutely correct. Samria's answer is correct. Now see, my dear friend, first of all, if you're not able to understand, let me tell you, this reaction is CC, that is Claisen condensation, Claisen condensation, and it will react. How the Claisen condensation will take place, for that you have to see the Claisen condensation mechanism. So your A is like this, CH3CO, CH2, C double bond O, OC2H5. The hydrolysis will take place. So hydrolysis means reverse of esterification. So what you are going to get, this is carbon delta positive, oxygen negative. So OH will come over here and H plus will come over here. So your B will be like this, CH3, C double bond O, CH2, COOH. Now if you are able to recall it in your examination, that this is being alpha carbon, this is being beta carbon. So but decarboxylation will take place. This is negative and this proton will come and join this. So your answer will be acetone. So my dear friends, I hope if these 2 points you are not going to miss, you will get the correct answer. This is really awesome. This is really awesome. My dear friends, I'm going to tell you very important thing about this reaction, because I've told you that decarboxylation, beta keto acids, they can easily lose carbon dioxide. Now, another reaction, esterification. I was telling you that this hydrolysis is just reverse of esterification, and esterification is given in NCERT. So I'm going to give it 15 stars, my dear friend. That indicates that reaction is very important. And simply I'm going to write C. If I write R, C double bond O, OH, now you know that carboxylic acids are famous for losing proton, but whenever carboxylic acids are coming in contact with alcohol, they are unable to lose its proton. So suppose examiner has given O18. Now kids, let's see, it is very important. Who is going to lose its oxygen? So it should be like this. This acid will lose it. The acid will lose its OH, and that is going to eliminate out H. This is really very important, my dear friends. O has been lost by carboxylic acid in this reaction. Carboxylic acid losing its hydroxyl group. This is very important. Losing its hydroxyl group. Losing its hydroxyl group. Losing its hydroxyl group. This is really very important. And I will show you the mechanism also, my dear friends. You won't be able to believe it. That's why even NCERT has written the mechanism, that no one is going to believe that the one who was always giving its proton, now what happened to this carboxylic acid? Why this time it is losing its hydroxyl group? Why? This is a $1 million question, my dear friend. This is a $1 million question. Now, first of all, let me write down the product. The H2SO4 is dehydrating agent. So product will be R, C double bond O, O. Let's take it R dash. Now the oxygen will, O18 will be there. Now kids, you must be thinking, why O18 over here? O18 can be there because the examiner cannot use colored pencils, colored pen or colored molecules. So they will either mark a star in the examination or they will write O18, that is radioactive oxygen. Wherever they can place O18, doesn't matter. Now, what is formed? This is formed, and this is equilibrium. Whenever there is equilibrium in the reaction, one scientist always starts jumping. Who is that scientist? Le Chatelier. Now, Le Chatelier principle says if you eliminate out water, the reaction will go, the equilibrium will go in the forward direction, and if you're going to add more water, then the equilibrium will come in the backward direction. And water, this H2SO4, so water plus H2SO4, I can say this is dilute H2SO4. They can use a trick for this, just to confuse you, they can write dilute H2SO4 in this place. So Le-Chatelier principle says this H2SO4 should be concentrated if you want to carry out this reaction in the forward direction. This is the Le-Chatelier principle, and you can relate it with the chemical equilibrium chapter, my dear students. Now see. No, Shiv Kumar, there will be no short break because okay, how many of you want to have a short break? Because somebody's battery must be discharged, someone of you must want to eat apple or like that. So 10 to 15 minutes break, how many of you need? Just do let me know, then I can give you a break. Do let me know. So I want to see, at least make it 70 likes or 64 only. By 64, my dear friends. Now see, this is the reaction. Let's proceed towards its mechanism, but before that 10 minutes break. Okay, yeah, so I will start after this because 6 to 8 2 hours have been gone. So let's have a break for 10 minutes. Let's have a break, short break of 10 minutes, short break. Let's meet at 8:10 p.m. Okay, have something and let's enjoy. Let's have water, some juice or apple or whatever you want to have. Yeah, don't worry. Let's have 10-minute break. Okay, let's have 10-minute break. Don't worry, everyone. Let's have 10-minute break. Hey all my dear students, Baba HSP is back. Are you ready? So I'm in time, my dear students. As you can see, we are going to move towards this esterification reaction, as I've told you before the break, the esterification. So come on, everyone. This was a short break. Samriya is there, Shivakumar, Priyanka, and all my dear friends. Let's deal with this esterification reaction. I hope that everyone is ready. Jyoti is there, Krishna is there, Samriya is there. Everyone is back on time. So let's see, my dear friends. Let's continue with this esterification reaction. So let's move towards esterification. In esterification, let's take RCOOH. This acid I've taken, and there is H2SO4. Just see to it how many types of molecules are there and what they are going to do. This is the H2SO4, and there is also alcohol. Now you know that very well that H2SO4 is famous for donating its proton. So everyone, you have to understand and you have to move along with me. This H2SO4 will definitely give proton. This is an acid, and acid is always known for donating proton. Now this proton is confused. Proton is confused. See why it is confused. That there is acid, there is alcohol, and all they are having lone pair. This acid is having their lone pair, here lone pair, here lone pair. Number of lone pairs are present in the beaker, because all these three type of entities are present inside the beaker only, right? They are in beaker. Now this proton will attack on which oxygen? Let's say this is A oxygen, this is B oxygen, and this is the X oxygen. So this proton is very much confused on which oxygen should I attack. So is there anyone who is going to tell me that H plus is going to attack on which oxygen? So let me tell you, this H plus is going to attack on this oxygen, but could you please help me to know the reason why only it is going to attack on this oxygen only? Why not on other oxygen this proton is going to attack? So you will find it very difficult to answer it. Let me tell you, this oxygen is having, due to minus I it's delta negative, and due to minus I it's delta negative. But this oxygen is having attached with pi electron, and this pi electron is providing more electron density. So this oxygen is maximum electron rich. So this proton is going to attack on that oxygen only. After the attack, let's see what is going to happen. This R C double bond O positive H will get formed because it has lost its lone pair. Now this is protonated carboxylic acid. The oxygen got positively charged, and oxygen is highly electronegative. So oxygen is saying, oh, what happened to me? I've lost my electron. I'm being more electronegative than carbon. Hey carbon, I cannot tolerate this positive charge. So what I'm going to do, I will withdraw my pi electron, the support of pi electron from you, and I will make you positive. So it will look like this: R, C positive, OH, and OH. Now carbon is electron deficient. Carbon is right now having just 6 electrons. Carbon started crying, oh my dear, who has done all these things? So somebody said, hey, there was one H2SO4. H2SO4 has donated proton, and that proton has attacked on oxygen of carboxylic acid, and the oxygen has become positively charged to form oxonium ion, and then oxygen said, hey, I can't tolerate this positive charge, so oxygen has withdrawn pi electron. Yeah, you are right, Jyoti, you are absolutely correct. Now, this carbon is saying, hey, alcohol, what are you doing? What are you waiting for? Just come near to me. Come on, come on. You are having 8 electrons and I am having 6 electrons. So, oxygen, I will snatch 1 electron from you. So, this carboxylic acid is going to snatch 1 electron from this alcohol. So, just remember what I am writing. White color have used for carboxylic acid and the yellow color has been used for alcohol. So this alcohol's oxygen is going to donate 1 electron to this carbon. Carbon, while taking 1 electron, will lose its positive charge because it has gained 1 electron. Neutral. It has become neutral with 7 electrons, and oxygen, because its 1 electron has been stolen by that carbon, so it will get positive charge, and 7 electrons, both are having 7 electrons. So both will come together. Now see how they will look like. R, C, OH, OH, and this alcohol part, R, O, positive H, and this is the new bond form. Now oxygen once again will start shouting. This oxygen has started shouting, oh, what happened? Even I have lost my electron. 1 electron has been lost by me. I can't tolerate this positive charge. So this oxygen will snatch 1 electron from this hydrogen, because he said this all has been started by you only, because you have come from H2SO4. Just get away. Just get away from my life. Now this proton is searching, hey, where should I go? So H2SO4 has become HSO4 negative, and this is saying, hey, I'm being very, very strong acid. My pK is -4. I'm not going to take you back. So just see who is going to take you. So this proton is going to attack on this oxygen. This oxygen is of alcohol and this is of ether. Alcohol's oxygen is less electronegative than ether's, because in ether the bond angle is 111, in oxygen the bond angle is about 109. More is the bond angle, more is the electronegativity of that central atom. So this will go and attack over here, and even if you are not able to understand, then try to think that this cannot eliminate out as water. So this is going to attack on this lone pair. Now let's see how they will look like. Just see, because all the reactions steps are reversible. So now see, RC, OH, O positive, H2, and this alcohol part, OR. Now you see, this is the situation right now, and let me carry out this on the next page. Now see, this is going to eliminate out as water. Now see, who is forming water? During the water formation and during the elimination, who is going to lose its oxygen? This white oxygen was of carboxylic acid and the yellow one was of alcohol. Now you see whose oxygen has been eliminated out. So you can see very clearly that carboxylic acid is going to lose its oxygen. So it will get, yes, positive charge. This carbon will gain positive charge. Now after that, what is going to happen? Let's see. This will eliminate out its protons, so this will have negative charge, and you can see R, C double bond O, OR will be the answer. Now on this page only I am going to write it down so that clearly it is visible. R, C double bond O and OR. Now it has been proved that O of carboxylic acid has been lost. It is very clear to all of you. Now, what type of question they can ask you in the examination? That rate of esterification, that holds a lot of weightage. So remember that if I talk about rate of esterification. So remember that, my dear friends, everyone just see to it that what I am going to tell you, rate of esterification, rate of esterification is inversely proportional to steric hindrance. Just remember this point, steric hindrance, because this type of question can be asked as rank deciding question, that rate of esterification is inversely proportional to steric hindrance. This holds a whole lot of weightage, and this is really very important. Now, how the question can be asked on this point and what type of question they are going to ask, just see to it. Suppose if the question is like this, compare the rate and write it down in the decreasing order of esterification. With acetic acid. Now, option A is given like tertiary butyl alcohol, option B is given like isopropyl alcohol, option C is given like ethyl alcohol, option D is given like methyl alcohol. So it's very clear, but I want to see answer from your side, my dear students. I want to see answer from your sides. Yeah, you have to remember the names. Anshika, names you have to remember, because it's not necessary that they are going to give you the structure of these compounds. Even they can give you the names of these compounds. So let me write down even the names, and I can see DCBA. Everyone is writing answer DCBA. So I'm coming to that point, but before that, let me write down the names, because one girl is writing that names. Yeah, my dear friend, tertiary butyl alcohol, you have to remember the names. 100 of times I have told you, just keep the names. This is isopropyl alcohol, isopropyl alcohol. This is ethyl and this is methyl alcohol. This is maximum sterically hindered. So answer will be like DCBA. How many of you have got this answer? And this is absolutely correct. Now, after this, one question must be coming to your brain. Sir, you have changed alcohol. Is it possible that they can change the acid? Yeah, they can give you a question like this also. Just see, compare the rate. Compare the rate with ethyl alcohol. So they have given reaction like this: RCOOH plus ethyl alcohol. See the ways in which they can frame out the question. Number of types question can be framed. Now see, A, they have given CH3 COOH. B has been given as formic acid HCOH kits. Remember the names also, because they can give you the names also. Formic acid. Now C, they can give you compound like CH3 CH isopropyl and COH, and compound D like tertiary butyl and COH. They can give you such type of compounds, and they can ask for the rate. Now, my dear friends, This type of question can also be given. Now, how will you find out the answer in the decreasing order of the rate? I want to see in the chat section that what answer you're going to get, my dear students. Fast, quick. I want to see. And likes are 67, my dear friends. Smash, hit the like button, my dear students. Make it 70 at least. So, BACD, BACD, absolutely correct, my dear friends. Really, you are rocking. BACD, absolutely, because we have just to focus on that steric hindrance should be least, whether you are changing the acid keeping alcohol constant or you're changing the alcohol keeping acid constant. So, now after this, let's move towards another name reaction. And my dear friends, after this, another name reaction, just think of another name reaction. What type of name reactions we missed? There is one reaction named as, yes, the Shanku reaction. Have you ever heard the name? Have you ever heard this name, the Shanku reaction? Name is important. This reaction, I would like to say it's not that important, but yeah, reaction's name is the Shanku reaction. The Shanku reaction. The Shanku. Now, I'm just giving 4 stars. That means this reaction you can do in the match the following also, and this is missing in NCERT. Missing in NCERT, but yeah, examiner can give you this question. Missing in NCERT. This is not given in NCERT. Missing in NCERT, my dear friends. Let's see. This reaction says that RCHO. Now, whenever the name RCHO comes, we always think about aldol and Cannizzaro. Whenever alpha hydrogens are there, acidic alpha hydrogens, then aldol condensation will take place. And whenever acidic hydrogens are not there, alpha hydrogen is missing and concentrated NaOH, Cannizzaro reaction will take place. But this reaction is special reaction. This says with or without alpha hydrogen, aldehyde with or without alpha hydrogen, with or without alpha hydrogen, on reaction with a special type of reagent that is known as triethoxy aluminum. The reagent is triethoxy aluminum. This is special reagent. This is very special reagent, and this says that a type of Cannizzaro reaction will take place. That means one molecule of aldehyde will undergo oxidation, another molecule will undergo reduction. So it is a type of Cannizzaro reaction. We are not saying this is Cannizzaro reaction. It is a type of Cannizzaro reaction, because in Cannizzaro reaction, one carbon was undergoing oxidation and another carbon on the same time was undergoing reduction. So this is, but you know that just like lion and goat or deer cannot live together, one is going to kill another one. So acid and alcohol cannot live together. So what is going to happen? This acid will lose its OH and this proton. So final product will be ester. Ester is the final product. R C double bond O and O CH2R. This will be the answer. And once the question, very special question has been asked in AIIMS examination, I'm going to deal with same question. Just see to it. The question was given like this. Number of students, they have lost their marks in this question. Just see to it whether you are going to get the correct answer or not. Just write down in your copy, and when I'm going to write down the answer, check yourself whether your answer is right or wrong, because the name is not important. It's very complex structure, but yeah, the structure must be given in options. Just you draw it in your copy, the answer, and whenever I'm writing on the board, You just check it out whether your answer is matching with my answer or not. That you're supposed to do. Now everyone, your time starts now. Try to do this question. Palak, very good. Done. Oh, that's really awesome. But yeah, I was saying that I have given you 1 minute time. So yeah, after 1 minute only, I'm going to write down the answer. Likes are 69. Keep on hitting the like button. If you have not smashed it yet. Now, my dear students, let me write down the answer and check it out, everyone, whether your answer is getting matched with this or not. Is this your answer? Is this your answer, my dear students? Just check it out. Now, those who are not able to understand, for these kids, let me write down the intermediate one so that everyone can understand it. No need to cry if you're not able to get the answer. Just remain focused and definitely you're going to win the race, just like tortoise. So this is going to lose its OH. C double bond O, CH2R. This is going to be the answer. My dear students, everyone got it? Is everyone clear with this, my dear students? Do let me know. Now, after this, I'm going to tell you one reaction that is missing in NCERT, but it holds a lot of weightage. That is 15-star reaction. 15-star reaction. See to it. Name of reaction is Perkin reaction. I hope that you must have heard this name. Perkin reaction. Missing in NCERT, but very, very important. Missing in NCERT. So I will give 15 stars to this reaction. 15 stars. This is only one reaction, but very, very important. Definitely it will be asked, my dear friends. You liked it? Oh, yeah. Don't worry, Jyoti, don't worry. So, my dear friends, see, this reaction is when benzaldehyde is coming in contact with acetic anhydride. After this, I will give you questions, very, very important questions. CH3CO whole twice O acetic anhydride in presence of sodium acetate, CH3 COONA H3O plus. Answer is cinnamic acid. CH double bond CH COOH. The cinnamic acid is the answer, my dear friends. Cinnamic acid. This is the reaction. Just remember the names because it is very, very important. Its name is benzaldehyde. Its name is acetic anhydride. Its name is sodium acetate. Why this line? Okay, let's see to it. Gone. Gone. See kids. Everyone got it? Cinnamic acid is the product. This is really very, very important. Cinnamic acid. Now, I'm going to tell you somewhat less important reaction, but yes, you should know these reactions because they can come anytime and they can change your rank, your selection. Now see, the reaction's name is This reaction is only, I'm going to give it 2 star. Name is price rearrangement. Price rearrangement. Price rearrangement. You can also call it to be intramolecular Friedel-Crafts acylation. Intramolecular. Why I have given just 2 stars? Because it is missing in NCERT. Intramolecular Friedel-Crafts acylation. Friedel-Crafts acylation. Now just see to it, my dear student, what happens over here. There is this compound OCOR. Now you know that this oxygen is having lone pair, so due to plus M or plus R effect, this is ortho and para-diacting. So in presence of anhydrous aluminum chloride, anhydrous AlCl3, you will get 2 types of products. What are these 2 products? Just see to it. OH COR, OH COR. Now don't ask which one is minor, which one is major, because this reaction is in too much detail, but for you only this much is required because it is missing in NCERT and just have given 2 star to it. So just getting 2 stars, they are not going to ask which one is major, which one is minor. Otherwise TCP and KCP, number of things are there, but this much is only. Now let me tell you another reaction which is having 2 stars. That name is, 2 star means very less important. 2 stars means just you have to read it once. If you have completed all reactions of 15 stars, then you can get this reaction. Yeah, that this is intramolecular acylation. Yeah, Jyoti, you are right. Friedel-Crafts acylation, intramolecular. Yeah. Now see, its name is Baeyer-Villiger oxidation. Baeyer-Villiger oxidation. Baeyer-Villiger oxidation. So now, my dear student, what happens over here? If I take any ketone molecule, this is being ketone, and if I am reacting this ketone with peracid means, suppose if I have reacted with C6H5, C double bond OOOH. Why this is peracid? Because this is having peroxide linkage. This peracid they can use, or they can use MCPBA. What does it mean? Metachloroperbenzoic acid. Metachloroperbenzoic acid. So all they are nascent oxygen donor. Peracid are the source of nascent oxygen. So these are providing nascent oxygen. Now when they are going to lose nascent oxygen, that oxygen will come and insert over here, either this side or this side. Now your question will be whether the nascent oxygen provided by them will come to this side or this side. So I'm telling you it is 2 star reaction, but those who are preparing for BSc, MSc, that is going to hold a hell lot of weightage. But for you student, just remember that ketone will convert into ester, R, C double bond O, O, R. The ketone has converted to ester, and this MCPBA will convert into acid, RCOH, and hence the reaction got completed. Only this much is required for you, and you can understand it. Now after this, because in the match of following they can ask such type of question. Now I'm going to give you some more reactions of 3 star. Reactions name is Meerwein-Pondorf-Verlet reduction. So what are you saying? What is that? See kids, only 2 star I am giving you, 2 stars. Name of reaction is Meerwein-Pondorf-Verlet reduction. Meerwein-Pondorf-Verlet reduction. What is that? Meerwein-Pondorf-Verlet reduction in shortcut, you can say MPB. Just like somebody is using abusive languages like that. Meerwein-Pondorf-Verlet reduction. What happens over here? See kids, the ketone RC double bond O R is getting changed to secondary alcohol, that is RCHOH and R. The ketone has converted to secondary alcohol, and the reagent used is very specific. That reagent is aluminium isopropoxide. This reagent is very specific, my dear friends. What is the name? Aluminium isopropoxide. Aluminium isopropoxide. Wherever I am giving 2 star, that means this reaction is missing in NCERT kits, and definitely whenever these reactions are going to be asked, students start shouting that this is out of syllabus. Whenever the rest of the Indian students or whatever the students they will be shouting, you must be happy. Oh, my teacher has told you and I am going to do that. Now, aluminium isopropoxide. Aluminium isopropoxide, how it will look like? It will look like this CH3 whole twice CHO whole thrice aluminium isopropoxide. Now, my dear friends, just reverse of it, there is open-air oxidation. Open-air oxidation, what's that? Open-air oxidation, let's see what's open-air oxidation. Just reverse of it, there is open-air oxidation. It will convert it into back, and that is also 2 stars reaction. Open-air oxidation. Open-air oxidation. What is the name? Open-air oxidation. What reagent they are going to use for open-air oxidation? That is aluminium tertiary butoxide. What is that? Aluminium tertiary butoxide. Tertiary butoxide. Aluminium tertiary butoxide. How it will look like aluminium tertiary butoxide? It will look like this. CH3 whole thrice CO whole thrice aluminium tertiary butoxide. So both the reactions are of 2 stars and 2 stars. Now, my dear students, after this you must be thinking, wow sir, are these reactions missing in NCERT? So I will say, yeah, my dear student, all these reactions are missing in NCERT. And now, my dear students, let me tell you, just a second. All of these reactions are missing in NCERT. Now see to it, my dear friends. I told you I will tell you one reaction, that is Borodine-Hunsdiecker reaction. Borodine-Hunsdiecker reaction. Are you ready for Borodine-Hunsdiecker reaction? Borodine-Hunsdiecker reaction. Just see to it. This I'm going to give you 8 star for this reaction. This is important but missing in NCERT. Borodine-Hunsdiecker reaction. So this is used for shortening of the chain. That is very important point. Shortening of chain. Now, my dear friends, during Hoffman-Bromamide degradation, we have done the shortening of the chain. During decarboxylation reaction, we have done shortening of the chain. And now one more reaction which is used for shortening of the chain. This reaction is RC double bond O Ag silver carboxylate, when you are going to use X2 and CCl4. Now this X can be either bromine or chlorine. You will get Rx plus AgBr or AgX plus carbon dioxide. Decarboxylation, carbon dioxide will get eliminated out. Now see how this reaction will look like. Let's see with the help of one example. If somebody is going to take CH3 C double bond O OAG silver acetate, and they are going to react it with Br2 and CCl4. What answer you will get? CH3 Br will be the answer plus AgBr having Schottky and Frankland effect like this. Now you must be thinking, sir, if by chance iodine is given, then what is going to happen? Not chlorine, neither chlorine nor bromine. If by chance they have given iodine, now see, if they have given iodine, then the reaction's name will get changed. and this is having just two stars. Its name is Birnbaum Simonini reaction. Now let me come in front, and if I say, then you will start laughing. See, Birnbaum Simonini reaction. Everyone see my face. Birnbaum Simonini reaction. Birnbaum Simonini reaction. So what is going to happen? See, kids, if I am going to react R C double bond O Ag, some same silver carboxylate plus I2 carbon tetrachloride. Now my dear students, iodine is very good living group. The bond of iodine with carbon is not strong because carbon belongs to 2p and iodine belongs to 5p. This is very poor match. So the answer is ester, RC double bond O OR. So this will be the answer, Birnbaum Simonini reaction. So if examiner is going to give you such type of question, then what answer will you write? Kids, do let me know. CH3 C double bond O OAG plus I2 carbon tetrachloride. What should be your answer? I am waiting for your answer. Everyone, do let me know what answer you are going to get. Birnbaum Simonini reaction. So the answer will be yes, CH3 C double bond O CH3. Has everyone got this ester as the product? Now, my dear friends, you must be thinking, sir, all the reactions are cleared, all the reactions got completed, or still one or two reactions has been left? Now, my dear students, till now, just recall, try to recall which name reaction I haven't told you. The answer will come, sir, benzoin condensation. That is also 2-star reaction, but yes, it is there, and the name of reaction is benzoin condensation. You must have seen aldol condensation, Claisen condensation, but 2-star reaction, the name is 2-star reaction, benzoin condensation. This is also not given in NCERT, benzoin condensation. Let's see what is going to happen over here. Just see, if you are provided with 2 moles of benzaldehyde, now this reaction is very important. See why. And if you are going to react it with 50% KCN, now my dear friends, once you will get confused, you will say benzaldehyde 50%. Whenever you are going to see 50%, you will say Cannizzaro reaction. My dear friend, it's not KOH. If it has been given as KOH, then Cannizzaro reaction would have taken place. But this KCN is KCN. Just focus on KCN is there. KCN. So benzoin condensation, and you will get benzoin. How the benzoin will look like, just see to it. This is your benzoin. This type of compound is known as benzoin. Benzoin. This is reaction known as benzoin condensation. This is known as benzoin. My dear friends, is it clear to all of you till now? Now, if by chance in your brain any reaction is coming to your brain that you think that sir has not taught to us any reaction, just think of, kids, once you remember that I have given questions to Avengers batch students, at that time we have not completed name reaction. At that time you must be thinking, sir, we have not completed name reaction, and then you have given the questions based on that. Now today I have told you all the name reaction, and in the next lecture we will deal with all the distinguishing tests. Tollens test, Falling's test, Benedict's test, Carbylamine test. Now with this Carbylamine test, I think I haven't told you Carbylamine reaction. Carbylamine reaction is missing, isn't it? Hinsberg test, Victor-Meyer test. I will let you know all those tests, and then we'll do lot of questions. But I think Carbylamine reaction is missing, isn't it? It is given in NCERT. And this is very, very important reaction, my dear students. Carbylamine test or carbylamine reaction. Very, very important. 15 stars. 15 stars to this reaction. Carbylamine test or reaction. This test or reaction is given by primary amines only. RNH2. It must be primary amine. Before I start this reaction, everyone do let me know. Gabriel Thalamide. Yeah, I will come to this. Shiv Kumar said, Jeff, I taught you during elimination reaction, said Jeff. Okay. First of all, everyone do let me know. Gabriel Thalamide, I have told you in the previous lecture or not. Gabriel Thalamide reaction. Everyone, please help me. Gabriel Thalamide reaction, I have told you in the previous lecture or not. Please. Yes, done. Thank you. Thank you. I was thinking that we have done it. Thank you, my dear student. Thank you. Thanks a lot for your memory. Great memory. Thank you, my dear student. Now, this reaction, primary amine, whether this amine can be aliphatic or aromatic, for both aliphatic or aromatic. Now, in this reaction, it is reacted with chloroform and KOH. Now, with this chloroform and KOH, you must remember one reaction recently in the starting only we have done. Yeah, thank you, Jyoti. Thank you. Yes, Akanksha, thank you. Krishna, thank you. This reagent is responsible for Reimer-Tiemann reaction also, and this is going to provide dichlorocarbon, my dear friend. Now I can see in the chat section that you are really paying full attention. So, in the bonus, I will give you some questions. Wow, my dear friends, really, I'm happy. Now, this will form R, N, double bond and one coordinate bond C. This isocyanate is also known as carbylamine. This is foul smelling compound. Foul means unpleasant smell, unpleasant smell, unpleasant smell, or very, very bad smelling compound, very, very bad smelling compound, very, very bad smelling compound. And this is poisonous compound, kids. It is poisonous. Just remember that. During Hofmann-bromamide degradation reaction, we got isocyanate. In Hofmann-bromamide degradation, we got isocyanate as the intermediate. This is isocyanate. Just think of the names, because names will take your marks. Isocyanide, isocyanide. This is isocyanate, my dear friend. This is isocyanate. Remember that. This is isocyanate. So, if examiner is going to ask that aniline, but see, I'm going to give you one question, that this is benzamide. Now, benzamide reacted with KOBr. You know that KOBr. It has given A. Now, A has been treated with chloroform KOH. Now, what will be the product? B is what? Now, my dear friends, it's really important question for examination. Very, very important. You know that this is Hofmann-bromamide degradation. Either it can be given like this, or it can be given like KOH plus Br2, or they can give you like hypobromite. Even this name can be given hypobromite, and you know very well this is happy birthday reaction, Hofmann-bromamide degradation. CO will eliminate out and you will get aniline. Now this aniline is 1 degree amine, so this is carbylamine reaction, and you will get phenyl isocyanate as product. Phenyl isocyanate. Is it clear, my dear student? Either you can say this is carbylamine, or you can say phenyl isocyanate. This is your answer. I hope this is clear to each and everyone, my dear friends. Those who have got the same answer, show me the thumbs up, or you can show me the hearts, whatever you want to say. That what do let me know that your answer is same, my dear friends. You are getting the same answer. I want to see. Yes, I want to see, my dear friends, those how many of you are getting the same answer. Then I will start giving you question. But before start giving you questions, I would like to ask you only that how many of you want to deal with the questions, because number of reactions you have seen, that number of things we have done, number of name reactions we have done. So how many of you are ready to deal with the questions? Let's see how many of you are going to get marks on those questions, because number of name reactions we have completed. So I think that everyone is ready now. See, I'm going to write down one question. See, an organic compound, this is your question. An organic compound molecular formula is C5H10. C5H10. Okay, C5H10. This on reaction with O3, zinc and water, that is reductive ozonolysis, is giving out two types of products, A and B. A and B. Both A and B gives positive iodoform test. Iodoform test I taught you now. I told you iodoform test. Both are giving positive iodoform test. Both are giving positive iodoform test. This one is also giving iodoform test, and that is also giving positive iodoform test. Okay. Now compound A on reaction with dilute NaOH and heat has given croton aldehyde as the product. Croton aldehyde and compound B on reaction with concentrated H2SO4 has given macetylene as the product. Macetylene. Now the examiner is asking question, what is the IUPAC name of the starting compound? It's IUPAC name. Now do let me know, my dear friends, who is going to give the correct answer. What is the IUPAC name of starting compound? So how to do this question? Let's see, my dear friends. Are you able to do it or not? Yes. Yes, my dear friends. 2-methyl-butene. Samria has given the answer 2-methyl-butene. Let's see. 2-methyl-butene. Everyone, Palak has given the answer. Now let's see whether your answer is right or wrong. Let's see how to deal with this question. Always try to start from the back. This is indicating that this is acetaldehyde. A is acetaldehyde, the only aldehyde which gives positive tolerance or positive iodoform test. This is indicating that this is acetone. So A is acetaldehyde and B is acetone, right? So once if you are able to recognize that A is acetaldehyde and B is acetone, what you're supposed to do next step? next step is just to compress them. You're going to compress them. What you're going to get on compression, you will get CH3, CH double bond, C, CH3 and CH3. So this is the answer. Now IUPAC has been asked, iodoform test they have asked, aldol condensation they have asked, ozonolysis they have asked. In a single question, they have asked IUPAC, aldol condensation, iodoform test and ozonolysis. 4 concepts they have asked, my dear student. They have asked 4 concepts. You liked it? If you liked it, I want to see the hearts or the thumbs up. Then I'm going to give another question, a new question at the moment. Yeah, on the spot, I'm going to make new question. And this is my capability, that is my ability, that I can frame out any new question on the spot. So, let's deal with another question. Let's deal with another question, my dear friends. The question is, and if you are able to do such type of question, that means one day you will become genius. That definitely you are going to become genius if you are able to do such type of questions. An organic compound on reaction with NaOI gives yellow PPT plus sodium salt plus NaI plus water. Now the sodium salt is allowed to react with NaOH, calcium oxide, has given compound A. Now this A on reaction with O3, zinc and water gives 3 moles of glyoxal. Now the starting compounds, it's okay. Now let me know what is starting compound. What is the name of starting compound, kids? This compound's name, any name you can say. Name means either general name or the IUPAC name you can say. You can tell us any name. Yes, my dear students. Let's see who is going to give the correct answer. I'm waiting for your answer, my dear students. Acetophenone, oh my God, Krishna, Samria, you people are really doing stupendous performance. That's really fantastic. This organic compound is acetophenone. How you got it, I am unable to understand, my dear students. Very quick answer, very clear answer. This is acetophenone. Absolutely correct, my dear students. Absolutely. Samria, Krishna, all other students really rocking. Akanksha, Ataksha, Palak, my God, my dear students. Yeah, you can say 1-phenyl ethanol also. 1-phenyl, who has written 1-phenyl ethanol? Oh, ethanol. Yeah, Palak, 1-phenyl ethanol. Its IUPAC name will be 1-phenyl ethanol. 1-phenyl ethanol. In place of all, ethanol. My dear friends, that means you're loving such type of questions. You're liking such type of questions. That's really fantastic. Now I'm going to give you one more question. Just see to it. Just see to it. The question is, I'm really happy with your performance, that there is one ethene. Now this ethene on reaction with dilute H2SO4, it has given A. Now this A has been reacted with PCC. Reagents I haven't told you, so let me take PCC back. This A has been treated with KMnO4 acidic medium to give B, and this B has been treated with thionyl chloride, that is Jargen's reaction, to give C, and this C has been treated with H2PD barium sulfate, charcoal. It has given D. Now this D has been treated with benzaldehyde and dilute NaOH. This is going to be a tough question. I don't think that you will give answer easily. And heat. Now E, what is E? That is your question. Its name. This is going to be really a game changer question. And not easy. It's not that easy. And keep on hitting the like button, my dear friends. I want to see at least 80 likes, 5 likes more. Those who have not smashed the like button yet, smash it. Let's see who is going to give the correct answer. I'm waiting for your answer, my dear friends. Baba is waiting for your answer. In this way only you are going to become perfect. This is your exam before the NEET exam is going on. Let's see. What's your performance? What are your efforts? Yes, dear students. Three phenyl propanol 2-ene. Palak. So 3 phenyl. I think Palak's IUPAC name is going in the right direction. Palak, find out the journal name. I think your IUPAC is correct. Yeah, Jyoti and Palak, both of you are correct, because it's not mentioned that you have to tell IUPAC name or journal name. So its journal name is cinnamoldehyde and IUPAC name is, let's deal with. Now this is ethene and this reaction is being hydration. So hydration has taken place, just reverse of dehydration. So this is ethyl alcohol, and ethyl alcohol has come in contact with so strong oxidizing agent. So this is being acetic acid. This is being acetic acid, CH3 COOH, and this is CH3 COCl, and this is a Rosenmund reaction, isn't it, kids? This is being Rosenmund reaction. Rosenmund reaction. So you got CH3 CHO and CH3 CHO. This reaction is cross aldol condensation, that is Claisen-Schmitt reaction. I have taught you or not? Claisen-Schmitt reaction. And Claisen-Schmitt reaction, my dear friends. So this is your, this compound C6H5 CH double bond CH CHO. This is well known compound, that is cinnamoldehyde. Cinnamoldehyde. This is the journal name, common name, famous name. And if anyone is going to write down the IUPAC, then 1, 2, 3. So 3 phenyl propene. Its IUPAC name is 3 phenyl propene. 2N 1L. This is the IUPAC name. So you are enjoying questions, my dear friends. You are able to do such type of questions, even that tough questions you are able to solve. Really mind blowing, my dear friends. Mind blowing, really fantastic. So how many of you want more such type of questions? Show me the thumbs up and write down me. Write down me and thumbs up. Then only I'm going to give you questions. If you have got tired, then let's end up the session. And if you want questions, everyone write down me and thumbs up, me and thumbs up, and smash the like button, me and thumbs up. Let's see, is everyone ready? Then I'm going to give another question. If everyone is ready, what I want to see, let's see. I want to see likes to get increased. At least make it to be 80, my dear friends. Now let's see the question. Question is, an organic compound C5H10. You can see I'm making these questions right now. You can see how much concentration I have to apply. Now this on ozonolysis, reductive ozonolysis, O3, zinc and water has given A plus B. Now this B on reaction with ammonia gives urotropine. And this B on reaction with concentrated NaOH has given two products, methyl alcohol and sodium formate. Now if we talk about A on reaction with dilute NaOH and heat, no aldol condensation. This is going to be really tough. But on reaction with concentrated NaOH, exceptionally it undergoes Cannizzaro reaction. Now, what is IUPAC name of this compound? This is a really rank deciding question. This is going to be the rank deciding question, tough question, rank deciding. It's not easy to do it. Now let's see. Swami Hassan. What do you want, Swami? What happened? All my dear friends, I know each and every one of you very well. Baba means pent one in, kids. Yeah, I know, Swami Hassan, I know. Now, my dear friends, 3-methyl butene, Acharya is writing 3-methyl butene. So my dear students, number of students they have written pent 2 in or 1 in, that can't be the answer. Now let's see what will be the answer and how to find it out. Now, my dear students, this is C5H10. One thing is very clear from B, that this B is formaldehyde. HCH double bond O, and that's why it is showing Cannizzaro reaction and neurotropin. One carbon has lost. Now only 4 carbons are left. Now 4 carbons are left, and this is showing Cannizzaro reaction. That means A is also aldehyde. One thing is clear, this is formaldehyde. From these two results we got this is formaldehyde, and this is aldehyde of 4 carbon atoms. Now see, aldehyde with 4 carbon atoms, what is possible? So see, if I write this aldehyde with 4 carbon atoms, definitely it will show aldol condensation, but they are saying that no aldol condensation, so this is wrong. Now what can I write? I can write another aldehyde like this, CH3, CH, CH3, CHO. Only these two options are there, and this compound is having just one alpha hydrogen atom, and for aldol condensation at least 2 acidic alpha hydrogen atoms are required. So this is correct. Now combine this one and formaldehyde. What will you get? On compressing these two, we'll get the answer. That is CH3, CH, CH3, CH, and double bond CH2. So the answer is 1, 2, 3, 4. 3-methyl but 1-ene. 3-methyl but 1-ene is the correct answer. 3-methyl butene. 3-methyl butene is the correct answer. How many of you got the correct answer and how many you liked it? Yes, I hope that everyone enjoyed today's session, and I think that everyone has enjoyed today's lecture. Now my dear students, in the coming lecture we will deal with reagents. Once I'm going to tell you tolerance test. One more. Okay, I will give you one more, Krishna. Tolerance test, spelling test, Benedict test, Lucas test, Hinsberg test. Number of these tests. Once we are going to deal with Hoffman mustard oils test, then we will deal with such type of questions definitely. But Ajay, hey Baba, I'm in trouble about ordering what to do. I will let you know. Don't worry, don't worry, don't worry. Now, Krishna said one more question, so let's deal with one more question. See kids, everyone, as on public demand, let's deal with one more question. See to it, everyone. Krishna, you just give me the chemical. I will start question from there. Krishna, you just give me any chemical compound. I will start giving you, framing the question from that point. Just give me any chemical. I will start from there. Ratna Raju is writing benzaldehyde. First let me explain this question, then I will give you. So this is giving urotropine and Cannizzaro reaction. So this is formaldehyde. One thing is clear, formaldehyde. Now out of 5 carbons, 1 is of 1 carbon, so only 4 carbons left, and this is giving Cannizzaro reaction. This is indicating that this is aldehyde. Now aldehyde with 4 carbon atoms, 2 options are also only possible, and if we consider this is having 2 acidic alpha hydrogen atoms. So on reaction with dilute NaOH, it will give aldol condensation, but they are writing that it is not giving aldol condensation, so only we are left with one option. Got it? Benzaldehyde. Now see, I'm going to start with benzaldehyde. Everyone just see to it. as Krishna said, start from benzaldehyde. So I am starting from benzaldehyde. Now, benzaldehyde NH2 gives A, KOH ethylene glycol gives B on reaction with CrO2 Cl2 CCl4 H3O plus gives C on reaction with KMnO4 KOH or KMnO4 H plus gives D is reactive with the ammonia gives E on strong heating gives F on reaction with Br2KOH gives G is reacting with NaNO2 HCl ice cold solution giving H on reaction with HbF4 heat is giving I is reacting with NaOH 623 Kelvin temperature, 300 atmosphere pressure, H plus is giving J is reacted with zinc dust given K is reacting with O3 zinc and water has given L has been reacted with Hi red phosphorus has given M. Now M is reacting M has been reacted with Cl2H nu given N has been reacted with KOH aqueous given O has been reacted with concentrated H2SO4 443 Kelvin given P has been reacted with Br2 given Q is reacting Q has been reacted with KOH alcoholic heat given R has been reacted with NaNH2 heat S has been reacted with NaNH2 T has been reacted with NaNH2 U now U has been reacted with methyl chloride V has been reacted with sodium liquid ammonia W is reacted with O3 zinc and water X. Now kids, what is X? Because no space is left. Find out X. Because yeah, Ajay, I'm just trying to do that. So I must have Ye Palak. Hey everyone, Huge round of applause, my dear students. See, these are my students. I have given such a lengthy question, but on the spot, I got the answer from Palak. Everyone, yes, it's a time to celebrate. See, kids. Oh my God. Yay. Palak. Now, kids, how much happy am I? You don't know, my dear students. Really awesome, really awesome, really awesome. Everyone, see, such a fantastic answer. Palak, really, 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 what to say. And only not Palak is there. I know that rest of other students, Jyoti is there, Samriya is there, Krishna is there, Shivakumar is there. Number of students are there, those who are equally good. But as I have written X and I got the answer from Palak, my dear students, now only few students are there in India, and India is best in the world, and only few students will be there in India, those who are going to give such type of answer. My dear students, those who are watching this video, kids, you see Krishna has given me benzaldehyde, and I have framed this whole question right now. There's no one, this question is not the repeated one. Right now on the spot, I framed one new question, and you see kids, they are able to give the answer. There is Anish. You know that Anish has given number of answers. Sujay is there, who has given number of answers. Krishna is there, Palak, Shivakumar. All these kids are really brilliant. Now let me explain, my dear students. This is benzaldehyde, and till this is Wolff-Kishner reduction. So this is your toluene. B is your what? B is toluene. B is toluene. Now toluene with this is Itard reaction. This is being Itard reaction. You see, this is being Itard reaction. So this is benzaldehyde. Benzaldehyde oxidation. This is benzoic acid, and this is benzamide. Now benzamide has undergone happy birthday reaction, Hofmann bromamide degradation. No, this is not benzamide. This is ammonium benzoate, COONH4, and if you heat it, this is your benzamide, right? This is happy birthday reaction, Hofmann bromamide degradation. So this is aniline, and after aniline you can see this is diazotization, so benzene diazone chloride, and this is Kolbe-Schmitt reaction. So this is fluorobenzene. Fluorobenzene is undergoing Dawes process. So this is being phenol. You can see this is being phenol. Phenol zinc dust benzene ozonolysis, 3 moles of glyoxal, right? 3 moles of glyoxal. This is reduction. So this is ethane, and ethane, this is free radical substitution reaction. So this is ethyl chloride, and this is ethyl alcohol. This is ethyl alcohol. So dehydration, this is being ethene, and this is being ethane. Then after this Br2KOH, KOH elimination. So this is acetylene, this is acetylene. So acid base neutralization, 2 acidic hydrogen atoms. So you got disodium acetylide and disodium acetylide, methyl chloride, both the side, and this is Birch reduction. So transalkene hydrocarbon, we got ozonolysis. So we got 2 moles of acetaldehyde, and this is your answer. My dear student, even teacher has taken this much of time. I'm being your teacher. I took this much of time, and Palak has done this question within fraction of seconds. And once the question got completed, Palak has given the answer. Today's history. Once Anis has given such type of answer, Jyoti was there. Jyoti was also there, and Jyoti has given the answer. Jyoti, do you remember that day? Jyoti, do you remember that day when Anis has given the answer and then you have given the answer? Both of you were really done that time the fantastic work. And now today Palak, and that day I have told you not only the Anish and Jyoti, number of other students will come over there and they will be there to give the answer. Now, number of students we are having. Now, my dear students, Krishna, in the next session, I will tell you, my dear students, in the next session, I will come with the distinguishing test. And once the distinguishing test you have done, the chemical test you have done, now you will become star. And today, really, I'm glad, my dear students. Baba is happy. Today, Baba is happy, and you have shown your stupendous performance. God bless you, my dear students. Love you all, my dear students. Malar, Vanan, Jyoti, Kandraj, Krishna, all my dear students, really, you are doing great efforts. Your efforts will really, they will be there in your success. They are going to give you the best rank, my dear students. Bye, kids. Let's see you in the next lecture of distinguishing test. Okay, and how much you like today's session. The Palak's efforts, Jyoti, Krishna, Shiv Kumar, number of students are there. Samriya is there. So everyone, don't forget to write down in the comment section. I want to see. Yeah, Ajay, I will give you each and everything, concept wise, topic wise, each and everything. But I want to see your comments in the comment section. Just promise that you are going to. Samriya is really very intelligent student. So everyone, Jyoti, Samriya, Krishna, I know your names, my dear students. Ajay is here, Krishna is here. Bye to all of you. Good night. God bless you. Love you, my dear students.